Thanks for joining. Today is day number 2, and today we are going to discuss basic things only. SD-WAN, architecture, their component. If you have any doubt, you can ask, and then I will go and walk you through the vManage dashboard. So these topics I am going to cover today. All right. So what type of components we have in SD-WAN? You can answer because it's very easy. I'll write.
vManage,
What is the use of vManage?
doing the configuration and push them on the devices.
Config management. Yep. API integrations,
Yeah, we can
then
do pretty much everything from here. So iOS upgrades, anything what we need to do.
all operational tasks, etc. Right? All right. Then second component we have is vSmart. What's the use of vSmart?
Control plane processing, I will say.
This is the control plane, and in SD-WAN, control very much meaning routing. Very much
Yeah,
like.
the logic of the routers, basically.
All right. Then what about the vBond, the third component we have?
Orchestration component.
That is very much there for orchestration of the fabric. Okay, and then you have the VS devices or you have CS devices. That is your data plane devices, right? Very easy, straightforward. There is no much, you can see that separation in terms of no much argument, you can say. Point here is this, that some of the devices, so one of my students asked me that why for different things they have different devices, because some of the SD-WAN vendors, they have everything in one device. Like one device can work as a manager, smart and bond. Here in Cisco, why we have different components to doing different things? Answer here is this, that Cisco is mostly suitable for enterprise network, and they want to segregate all these networking components. They want different point of or isolated point of failures. Plus, they want different layer of security, and security is always in layers. So that's why we have this layered approach. Different components are doing different things. Although the usability is also different. So when we are talking about this vBond component, this is for orchestration. It is going to orchestrate. So basically, vBond is a device. Suppose vBond is a device which is very much connected or can be connected with internet or outside world, where Cisco has their PNP portals, plug and play portals, where you have some virtual accounts mapped with your smart accounts, where you have all the device list, and there you can go and have the controller profile. So that particular model or list of the devices with serial number and the chassis ID can be seen by vBond, and then vBond will go and educate that particular thing to vManage, and then vManage also having that database. So basically the database that the vBond will download from the parent orchestrator, it can be shared with vBond and vSmart, because then vBond and vSmart, they can go and communicate. So then the vManage and vSmart, they can go and communicate with the vEdge devices. Now suppose if you have to onboard vEdge device, so vEdge device, first it has to go and get authenticated from vBond. So what vBond will check? vBond will go and check the serial number, chassis ID of vBond. So vBond will check the serial number and the chassis ID of vEdge, and vEdge, this vEdge device will go and check the organization name of vBond. So they will do some sort of mutual authentication. And once this authentication will get completed, then only they will go and form the DTLS or TLS connection. DTLS or TLS connection, either UDP based or TCP based connection they will do. Now, very interestingly in SD-WAN, once this thing has been completed, then it will tear down this tunnel and you have the permanent tunnel only with the controllers, with vManage and vSmart. So with vManage and vSmart, you have the permanent connection, permanent connection, permanent tunnel, the control connection. With vBond, once you get authenticated, this tunnel will get tear down. The same way, when you are removing the device from the fabric, if you remove the device from the fabric, again they will establish the communication with vBond. And once vBond will go and remove that serial number chassis ID from their list, they will tell this to vManage and vSmart, and likewise this device will get removed. So vBond usability here is this, that they are there, they are used there to build the orchestration plane, to build the fabric, means which particular device will join the fabric or they are leaving the fabric. That's the main usability we have with the vBond. Okay.
Okay.
All right. So now let me redraw this diagram one more time. So if I have to go and bring the fabric, first of all, I will go and bring the control plane or controllers. So controllers, what you will do, you have vManage, you have vBond, you have vSmart. Now these control plane devices are controllers, not control plane devices. These controllers, what you will do, these particular controllers, you have option. Either you can go and use some cloud hosted partner, like 90% of customers, they are using either Cisco Cloud or some third party cloud for controllers. Only 10% companies, they have their own controllers in somewhere in data center or somewhere, right? So in case either it's hosted or it's running in your data center, what is there? These are the softwares, right? So you need some sort of compute where you can go and install these softwares and it will work. No problem at all. You will go and install and it will work. Now, once you have these controllers, control plane up and running, then you will go and create your data plane. So your data plane devices will go and get authenticated with these devices and they will be the part of the fabric. Now, there are steps. There are certain steps to do so. What are those steps? So let's quickly discuss about this. Now, even if you are bringing up the control plane devices, what you need to do, that first of all, obviously you need software and the licenses. Then second thing you need some basic configuration to these devices. Now in this basic configuration, what you need at least the system IP, org name. Obviously, let me start with the host name, say name of the device, then the system IP, then the organization name you can say, then the reachability to the vBond. And what is there? 5 things are there, right? Site ID. These 5 parameters are there. That is minimum basic configuration that you want to do. And then finally, you will make sure that your certificates are working properly. And the last thing is the reachability, routing between controllers, or in case if you have the edge devices, you should reach to your devices as well. Otherwise, obviously, they will not work. Okay. So these are the basic things related to the controller devices. Now, what about the edge devices? For edge devices, what you need? Obviously, for edge devices also. So edge devices may be software, may be hardware. So suppose these parameters are related to the controllers. Then we have the edge devices as well. So for edge devices, point 1, you have software and you have hardware option as well. Then you need point 2 as it is. Then obviously you need certification as it is. And then obviously you need some routing configuration as it is. What extra thing that we are doing? What are the extra thing that we are doing that is interesting? So what extra thing that we are doing in the edge devices? I'll come to that. Suppose I have to bring a vManage. Suppose I want to bring vManage. So what I will do with this vManage? I'll go and define 1, 2, 3. Let me do like this. I need some cable. Okay. Suppose this is my vManage. So what are the things I need to define here? So I need to define 5 basic things like host name, right? Site ID or system IP, system IP, site ID, org name, and reachability to vBond. Okay, these 5 parameters, basic configuration. They are part of what? They are part of basic configuration. But you need reachability, right? While we are talking about reachability, that means that you have interfaces, and later on I'll tell you that we have different type of VPN. We have VPN 0 termed as a transport VPN. This is how you will transport. Now you can see the road is not good at transporting. This is the transport, and then at least you need one more VPN that is for management. So that will be part of VPN. So some interface, suppose ETH0, Ethernet interface 0 is part of VPN 512. And for example, ETH1 is part of VPN 0. So apart from these parameters, you need what you need. You need the other parameters as well. The other parameters means that the VPN configuration. So how these devices can reach, either how you will reach to the device, and then how these management plane devices will reach to other controllers and other data plane devices. Now, here is the difference. When you are configuring the edge device, suppose this is the edge device, VH device. So let me suppose this is VH, one of the edge device. Now for this also I need transport. So one of the interface, for example, Gigi 0/0 is part of transport VPN, that is VPN 0, right? And then I need one management VPN as well. So I have, suppose, ETH 0 as part of VPN, as part of VPN 512, right? But here is the point. The point here is this, that you have other devices also connected with this device, other switches, LAN switches, other third-party routers or other networking routers are also connected. So for that, what you will do, that you need service side VPN. So you need service side VPN, and this service side VPN may be from VPN 1 up to VPN. Now it is more than like 65,000 something, but practically from 1 up to 512. So VPN 0 is there for transport. This is transport VPN. VPN 1 up to VPN 511 is there for servicing, service side VPN. They are termed as a service side VPN. And then you have VPN 512, that is for management purpose, MGMT. So whatever things that we are assigning, right, we have to do configuration as well. But remember, whenever you are doing configuration, the first thing is basic configuration. So you will do basic configuration. You will do basic routing. Sometimes it is referred as a bootstrap, like minimum configuration to bring up the device. So basic configuration you can do, basic routing you can do, and later on you can go and add the packages, more configuration, more robust configuration, all those things you can add later on as well. Okay. So this is very interesting. Like once you go and do these basic configuration, that is the phase number one. If you do all these things, then what will happen? That we are going to understand after this. Hi, Tony. Thanks for joining. Hi, Ugur. Thanks for joining. I'm recording this session. So uh, after this class, I think you missed 5 minutes or maybe 7 minutes. So please try to join on time and watch the recording. We have very interesting 5 minutes or 7 minute sessions, after you join. So you can watch the recording. Now, before we move further, if you have any question, please feel free to ask.
So for VH devices or CH, we don't need that part for certificates, right?
Everything we need certificates, yes.
We need, okay. So it will apply the same things for controllers plus this VPN 0 and VPN 512 plus service VPNs, right?
Yeah, so the control plane devices, they do not have service VPNs. They have only two VPN because it's not required.
Yeah,
We are
yeah,
not.
I'm talking about
Yeah,
the
yeah.
second part of the AGs.
Oh, okay, okay, yeah. Service VPNs, yeah. Yeah,
Yeah.
got it, yeah.
Okay. Maybe one thing to deploy the edge devices. First, okay, you need connectivity between the vManage and the edge devices, and that will go through the VPN 0, which is the transport.
Yeah.
Okay. Okay, so then even though, let's say the transport VPN is configured between the edge devices and the vManage, we still need the management VPN 512.
Yes. Management
Yes.
VPN 512 is there for management traffic and where you will not send your IPsec tunnel traffic and all. Just to log into the devices, managing the devices, we have the out of band management IPs and the interfaces.
Okay. Okay, good.
Okay, any other question? Please feel free to ask.
So the higher range from 513 until what is the maximum you said for the
Yeah,
service VPN?
nowadays we have up to 65,000,
Okay.
but it's not required that much VRF in a network. 4 to 5 VRFs are more than enough in enterprise network. So VRFs that we are using nowadays, you know that VRF employee, VRF guest, VRF corporate, like that.
Yeah.
So it's very less
Is there
number of
any
VRFs.
limitation how many VRFs you can use on those devices?
Yes,
Like
obviously
maximum?
limitation is there. Theoretically, it is 65,000. Practically, it will be less than 100 or 200. Like, you
Mm-hmm.
can check the
Okay.
device capacity, capability. More number of VRF. Who will use more number of VRF? ISPs will use. And for ISP, they are using different type of SD-WAN solution, like they are using Versa or any other. This is mostly suited for enterprise network, the Cisco SD-WAN.
Yeah.
Okay.
All right.
Yeah,
So
Vicar is asking a question on the chat, like where is the VPN 1 and 511 is used and why? So those are service VPNs for your basically your traffic, right? Going through your switches and whatever, how you design your network.
Yeah, it's same like VRFs basically for customers also and all those things. So for separate client, if you have some separate VRF.
okay, that answer your question, Booger. You understood? Think that VPN 1 to VPN 512 as a LAN. LAN side VPN. They are used in LAN. And then you have WAN, that is transport. Okay, great. What is happening? Continue presenting. Okay, so let's continue. So now we know that we need minimum configuration to bring up the fabric. Now in that minimum configuration, we have certain things. So what are those things? I told you that in basic configuration, you have the host name, you have the system IP, you have the site ID, you have the org name, organization name, and you have the reachability to vBond, or you should know the vBond IP. Now, what's the function? What's the use of all these terms? First, we are going to discuss about that. And then obviously after, once you do this, you need some routing. You need some basic, at least basic routing to all the devices should reach each other. But let's discuss about these important terminologies. These important terminologies that we have, right? These important terminologies that we have: hostname, system IP, site ID, org-name, vBond IP. Hostname is no, you know that this the name. Leave it. Now, question here is this: what's the use of system IP? Why we are using system IP?
So it's something like kind of loopback for the SD-WAN, I would say.
Loop back for the SD-WAN, 100% correct. Any other answer? Okay, loop back is the correct answer. And different systems having, I heard that it is free when you buy any device that support SD-WAN. Is it true? I didn't understand what you're asking, Google. I heard
Yes,
that it
yes,
is free when you buy
you
any device.
understand.
Okay, okay, no problem. So question here is this, that okay, loopback, it's like loopback address. What is the significance of loopback address in Cisco routers?
It's always reachable.
It's always reachable. Okay, that's correct. Any other?
Like the router ID in when you're using the routing protocols.
100% correct. So system IP is like a loopback address, and very interesting thing here is this, that you know that all the routers, all the devices, suppose this is some loopback address, all the routers devices, they have some physical interfaces, right? Now loopback interface is a type of interface which is always on, and if any of the physical interface is down, still it is on, because it's a logical interface, and that is defined as a ID or as a system IP. Okay, so that point is clear to everyone, and obviously it is used in different routing protocols as you mentioned. So point is clear. All right, now coming to the second point. So this is one, this is two. Third point, site ID. What is the significance of site ID? So whenever we are configuring any device in Cisco SD-WAN, we are assigning some site ID to it. What's the usability of site ID?
It's like kind of definition of the location. Or
Definition of the location. So I have routers, right? And site ID, I'll make this very simple. Like you mentioned, is a grouping of the routers. So routers, you can group together with site ID. If site ID is 100, so by default, these routers, they will not form IPsec tunnel with either, irrespective of location. One is in Sweden, one is in Denmark. Still, they will not form the IPsec tunnel if they are part of same site ID. Here also site ID 100 and router. So they will never form the IPsec tunnel by default. Same site ID, they are never forming the IPsec tunnel to each other. Now, if you have different site ID, suppose site ID, again, I have some routers here in this site ID, suppose two routers, and this having site ID, for example, 200. So then these site ID routers, they will go and form the IPsec tunnel to each other. Okay. The site ID, what is the significance? This is the grouping of the devices. Now, there is one more significance with this site ID. One more significance we have with this site ID. And what is that significance? The significance we have with this site ID is this, that in terms of policy, right? Whenever you will go and apply the policy, right? Whenever you will go and apply the apply policy is 100% of the time with respect to site ID. That is another interesting thing about site ID. Okay, so 1, 2, 3. What's the fourth item here? The fourth item here is this, the organization name. Significance of organization name. What's the significance? Why we are using this?
To generate and bond the certificates.
Yes, it is used for certification. Yes, 100% correct. Okay, and the last thing is the vBond, reachability to vBond IP. What does it mean?
That vBond has to be defined IP address and reachable.
Why devices should reach to vBond?
For initial setup to get the original communication with vBond.
100% right. So you know that when we are bringing up the fabric, all devices should go and reach to vBond. Now, if they do not have vBond IP, how they will reach it? So it should have reachable vBond IP, all the devices, even the controllers also. They should know the location of vBond, either their some static IP or their DNS IP, right? They should be able to reach to the vBond. Okay. All right, great, good job, guys. Okay, so now we know the basics, like, basic configuration to configure the devices. Obviously, we'll configure the device as well in upcoming classes. These are the very basic fundamental, and then obviously you need routing. Now, once you do everything behind the scene, how they will go and join the fabric and how their connections will look like, that I'm going to draw. This drawing is very important. That will help you to understand different pieces in a SD-WAN network. So for example, let me go and draw the controllers, and then we have the edge devices. I will name as well these devices, two edge devices. Suppose this is vSmart. Suppose this is vManage. Suppose this is vBond. Suppose this is VH1, and suppose this is VH2. I'll not go and draw the ISPs and all. Now, when first thing what you need to do is to bring up the SD-WAN fabric. Now, to bring up the fabric, once you go and bring up, you do basic configuration, routing, certification, then they will go and form the tunnel to each other. So you have the DTLS or TLS. I'll write the TLS here. The tunnel, secure tunnels you have. Okay. With these devices also. Dotted means temporary tunnel. Dotted means the temporary tunnel. So from here also. Okay. So this green one is what? DTLS. So once you go and bring up the fabric, you need to bring up the control connection, and then these devices that you have, these edge devices that you have, they will go and form the IPsec tunnel in between them. This IPsec tunnel is nothing but the data plane tunnel. Whenever you will send or receive the traffic, it will go via the IPsec tunnel, right? So this white one is IPsec tunnel. Now later on, we have to study that we have something called OMP, Overlay Management Protocol, that is going to run in between the controllers and the edge devices. They are not in between the edge devices to edge devices. They are in between the controllers to the edge devices. So we have the, let me change the color. Let me go and use some brownish color. So in between the vSmart and the edge devices, we have the connectivity. Actually, we have the peering, OMP peering. The protocol is running in between the vSmart and the edge devices. That is your OMP protocol, OMP protocol. And you know this OMP protocol. So suppose I have vSmart and I have the edge devices. In between, I have OMP peering. Okay. So this OMP protocol that you are running, within this OMP protocol, not only they are sharing, so what are the things they are sharing? First of all, they are sharing the IPsec key. So your vSmart will not work only as a control plane or route BGP route reflector, but they are working as a key manager as well for IPsec. Key management. They are doing the key management because they have all the IPsec key. While these edge devices, they are forming the tunnel in between them. They are exchanging their IPsec key with the vSmart. So they have the IPsec. Then they have the routing information. Suppose this is IPsec key information. This is routing update or routing information. Apart from that, they are sending one other thing as well. That is the policy. Whenever you'll go and create the policy, obviously you'll go and create the policy at the level of vManage, but vManage will push the policy to vSmart with help of Netconf protocol, network configuration protocol. But vSmart will use OMP to push that to the edge devices. Okay. This is very interesting diagram. I'll come to OMP separately, but try to digest this particular diagram first, and then I will specifically draw the OMP diagram.
Sorry,
Okay.
can I ask for that site ID again because I didn't get one part of it. So if we have
Site,
site ID 100, let's say, those routers will not create IPsec, you said?
yeah. So routers with same site ID will not form the IPsec tunnel by default.
But in this case, we have different site ID of wedge 1 and
Yeah.
wedge 2.
So they are part of different site ID.
Okay.
This is site ID, for example, this is site ID 100. This is site ID 200. Different site ID.
Okay. Yeah, okay. So to summarize, if I well understand, between the vSmart and the vEdge, the OMP will carry the IPsec management keys, the policy, and also push the routing details config. And between vManage and vSmart, go using Netconf, then vManage will push the configuration to vSmart.
Exactly.
Okay.
This is
And
what the
vSmart act as a route reflector to all the edges.
yes.
Okay. Okay.
Okay. All right. So what I'm going to do here now, I'm going to draw one diagram separate for OMP. Okay. So let me go and remove this. Let's focus on OMP. So for that, I need to change the color. I need, suppose I have two vSmart 1, vSmart 2, and then I have two vEdges, vEdge 1, vEdge 2 at different locations. So I have vSmart 1, I have vSmart 2, and then I have, say, ISP blue and ISP green. Now ISP blue and ISP green. So that means that when you are connecting, so colors are there. When you are connecting, you can reach to vSmart like this and vice versa. For this, I'm not drawing anything, but you can understand the logically they can reach to both the vSmart over like this. So I'll remove these diagrams, this connectivity, but assume that connection is there. Now, I want to go and form the OMP, diagram in between that how they are pairing and all. So let's try to understand that. Let's try to figure out that. So when OMP will get formed, how they will get formed. Over these tunnels, right? And again, so these I will remove this connection, but obviously you have the redundancy. Oops, you have the redundancy by which the OMP tunnel will get formed, right?
Mm.
Okay. Now try to understand this thing. So OMP I have in between them. They are OMP peers, and I have OMP here, and I have OMP here, and I have OMP here, and I have OMP here. Overlay management. Anyway, we have separate 1-day session for OMP, so don't worry about that. So if I go to vSmart 1, and if I try to see how many OMP peers I have, So what will be the number? vSmart1 having how many number of OMP peers?
5.
So vSmart1 having OMP peer, vSmart2,
3.
vEdge1, and
Yes.
vEdge2. What about the vS2? How many OMP peers it has?
2 VS1, 2 VH1, and VH2.
So it has VS, sorry, VS1 and VH1, 3, right?
Yeah.
And what about VH1? How many OMP pair it has?
2 VS1 and VS2.
100% correct. That's why I draw this diagram. So there is no OMP pair in between VH1 and VS2, right?
Great. Yeah.
It's not
Okay.
there. Okay. Getting the points. Any doubt? Anything? Please feel free to ask so far because you're doing good. All right. So now we have very interesting session related to dashboard tour. And apart from that, I will show you that with the help of vManage, how you can do the reverse telnet and log into devices. And I will show you the basic minimum configuration as well. And then I will show you that where is VPN 0, where is VPN 1, where is VPN 512. All those things I'm going to show you. So let's start with CLI and then we'll go to the GUI approach because we are very much familiar with the CLI thing. So let me go and connect with, I have already my VPN connected. VPN means the Cisco AnyConnect connected. So let me log into the vManage. Okay. Now you can see that I logged into vManage, and if I want to see the basic minimum configuration, so I can go and type show run system. And in this, you can see the basic minimum configuration that we were discussing. What is the host name, then the system IP, then the site ID. These are the minimum thing that should be present there. Then the vBond IP. So these 5 things will be there under system category. Then AAA configuration is there like normal Cisco routers and switches. AAA, banner, SNMP, log, NTP, all those things will be there. Then next important thing we want to see here. Let me go to vShell and clear this. You know this vManage, if you type vShell, you can go to the shell. And if you have some OS release, you can see the ID is Viptela. And let me exit from here. Let me go to the main cell. Now in this place, you can go and check show run. First of all, VPN 0 configuration. VPN 0 is your transport VPN. So you can see that VPN 0 is there. Under VPN, I have the interfaces. So I have one interface, ETH0 here. Over that, I have the IP address and rest of the tunnel configuration. Then finally, we have one default route pointing towards the ISP or towards the gateway. So this is the minimum configuration over VPN 0. Likewise we can go and check VPN 512 configuration, that is for management. It's not there because we are managing the device via this IP only. But we will see in the other devices like in data center devices and all about VPN 512 configuration. Now from here what I want to log in to the devices, to the other devices. So before that, I should know the IP addresses for those devices. What you can do from vManage, you can go and run command show control connections just to see your DTLS or TLS connectivity. So here you can see the tunnel type is DTLS. You can see DTLS. And what's the system IP? So it is forming the connection over the system IP from the source to the destination, source of DTLS tunnel and destination of the DTLS tunnel. And now you can see that it has peering with VH devices, it has peering with vSmart, vBond. So all tunnels are there, and you can see the status as well by the end of this column, up, up, up. You see up, up, up. So these tunnels are up and running. No problem with the tunnel. So they are good. They are up and running. Okay, good, great. So
So
now,
in VH,
Mhm.
this command is just show SD-WAN control connections, right?
Yes, control connection.
Okay.
Okay, and in case if you are looking for a license installed, so you can check that. You can, if you want to check the certificate, so you can check the certificate as well. Why the quit is not working? Okay, you're out. Okay, you can check. So certificate installed. You can see the certificate. In that certificate, you can see the organization name, OU. The organization. That's very important for doing um, the to form the to form the DTLS channel, not IPsec channel, to form the control connection. This is very, very, very important, right? Okay, great. So now what we want to check the control connection, because with that control connection, I will get the system IP of other devices. So I have data center device whose system IP is 10101. Other data center device system IP is 10102. And even I can see their physical IP as well, that is there over VPN 0. So what I want to log in from my vManage. I just wanted to log into the device and just wanted to see their configuration as well. So for that, I can move to shell. You can see this shell, Linux type of shell. We can move. And now from here, what we can do, we can SSH. If you know the username, suppose username is admin, I want to log in to 10101 just to see that if I can log in or not. Now it is asking about fingerprint and all. And then the password. So username admin, password admin. Let me try admin. And now you can see that I am inside DC VH1. So from vManage, I can telnet and go to the DC1 VH1, because from here I just wanted to verify that the DC1 configuration as well. So if I go here and type show run system, just to show you 5 mandatory things here: the host name, system IP, site ID, organization name, and the vBond IP. So these parameters we can go and check, right? Great. Then I can go and check VPN 0 configuration. So here you can see, since it has, first of all, say VPN 0, this is connected with two ISP. So gigabit Ethernet 0/1, which is connected with, you can see the color is MPLS, whose IP is 164.0.2/30. So this is my gigabit 01 interface and the tunnel configuration. Likewise, my gigabit 02 configuration, which is connected with, physically connected with internet, and whose tunnel configuration. So these are my two ISP interfaces and their tunnel configuration, right? ISP interfaces and their tunnel configuration. Now, if I want to see the VPN 512 configuration, that's the management. So here you can see that yes, I have management IP. This is what? This is my out of band management IP. So if I can open PuTTY, let me open PuTTY here and try to log in to this IP 198.183.100 with port number 22. I try to log in, asking me login as admin, password admin. So you can see here that I am within that VS devices, and I can go and check VPN 512. So now from this point, you should know that you have the basic minimum configuration. First of all, you should have the basic configuration to begin with. So basic configuration, where you should have the host name, site ID or system IP, so SIP, system IP, site ID, then org name and vBond IP. Should have this. Then you should have the VPN configuration within VPN. You should have the VPN 0. You should have VPN 512 for management. And then you should have VPN 1 up to VPN 511. That is for services. This is service side VPN. This is your MGMT management VPN. This is your transport. Right? And then obviously you have some routing. You can see default route under this and default route under VPN 0 as well. So those things also you have. Okay, so far you're with me?
Yeah,
Yes.
all good.
Okay. So one question, one interview question for you. Maybe if you go for some interview and they may ask you, okay. So which protocol is running in between vManage and VS devices?
OMP.
Okay, I'll ask you in other way. Which protocol vManage is using to configure their devices?
Mhm.
Okay, so answer is
Netconf? No?
no. Google is allowed. My friend, no chat GPT, no Google. We are smart and we are, yes, Netconf.
Yeah.
And Netconf, okay, other question. Netconf is using port number. What port number?
I don't remember.
No problem. It's port number 830. If you are doing SDA, software defined
Yeah.
networking, and if you're working
Okay.
for DNA with DNA, so for the telemetry functions and all to work, you need to enable port 830. Otherwise, all DNA feature will not work. So this is actually important for wired and wireless network. They are in SDA environment or in normal DNA environment. Port number 830, and we know that SSH is port number 22. So when I log in from vManage to this device, it may use port number 830. When I log in via PuTTY, it is using port number 22 to log in. Okay, so that's very interesting. People generally know, but obviously so many things people are doing. This is for interview purpose. Interview purpose means that this diagram that we have. So vManage can configure the devices whenever you push the template. So we have some device configuration template. Whenever we push the device configuration template from vManage to vEdge, it will use the Netconf protocol. But when you go and create the policy, any local policy or any, not local, but any centralized policy from vSmart and you will push to edge device, that will use OMP protocol. So in between vSmart and vEdge, the communicating channel or communication channel is via overlay management protocol. But from vManage to all the devices, The communication channel is Netconf. The protocol is Netconf.
Okay, so it
Okay, thank
means
you.
I can choose how I deploy the config on the vEdges.
Not really, because if you are managing it from vManage, I think you cannot do SSH config anymore, like conft.
Okay, okay.
So the whole idea is the configuration standardization, right? You want a
Mm,
standard configuration to all the devices, and some other guy will not go and change your configuration.
mm,
So
mm,
that's the reason everything is managed from the centralized plane, and
mm,
it is managed via vManage. That doesn't mean that you can't do anything. You can detach the template and you can do the changes, but again, just for troubleshooting, testing, and all those purposes.
mm.
After that, you
Okay,
should attach it via vManage.
okay, good.
All right, great. So these are the basic, very important basic things we have. Now let me quickly go and log into the vManage dashboard. So I have my connectivity and I can go here. We are here. The admin. So once you log in, now they have made this very much like looking like DNA type of dashboard. But this is your dashboard. First time when you log in, you can see this dashboard, right? Now in this particular dashboard, you have all those stats. So here you have the menu. I'll go to that menu. I'll show you multiple options. But without menu also, you can see that on top you have the controller list, WAN list, the health of the devices, the BFTs, the app route application or top application list, etc., etc. So it is nice, good, robust type of dashboard we have. And then further, what we can do, further we can go deep inside any of them. So suppose if you want to see the top applications, you can click here, you can go inside the application and you can see it. So let me show you that what exactly I'm telling you. You can click here. View details are there. You can see the details, right? So all these uh, things are clickable. You can click to manage. You can go to manage. Now the other nice thing about this dashboard is that not only that you have vManage dashboard, like vManage you can see in the GUI format, but you can see all these devices also in the GUI format. So what does it mean? I can click to this particular device, DC1 VH1, and I can go to DC1 VH1 GUI mode, right? Now, if we want to see some of the interesting thing like ping, trace route, etc., you can see in the bottom by the bottom of this dashboard, you can see the troubleshooting is there, real time is there. I can click to troubleshooting option, and then I can see the device bring up. I can see the control connection live view. I can see the ping. I can see the trace route. All those options we can go and do here from the GUI itself. So if I do ping, it is asking about what is the destination IP. I'll go and give say 10 dot. You can see one IP is there. This is one of the branch IP from VPN 0 ping. Like that, you can go and check the trace route as well. It's loading. You can see this reachable. 5 packet transmit, 5 packet received, right? So we can go and check that. Okay. So what I'm telling here is that we have the dashboard within dashboard. So you have your vManage dashboard that can give you the overall view of your SD-WAN. And then within dashboard itself, you have dashboard where you can go and check the individual devices as well. Not only you can check, you can do multiple things as well. So for example, if I want to run OSPF, show OSPF details, yes, you can do it. So if you come here, you can see real time option in the bottom. So if you click real time and if you go and search OSPF, OSPF database, OSPF neighbor, whatever. So OSPF database is loading. And you can see the OSPF database. This is very much equivalent to the CLI part as well, like show IP OSPF database, etc. You can see all these things, all these informations, right? So this is nice. Apart from that, you can see the connection events, the flows, the top talkers, the TLOC, the tunnel information. All these informations you can check from one place. That is your vManage. That is about the individual device. From vManage, what type of things you can go and manage, that is also there. For that, you can go to this menu option. If you go to that menu option, you can click here. You can see long list of things that you can do. First of all, monitoring. All these monitoring tasks, monitoring the devices, the tunnels, the security, the VPN logs, blah, blah. Then configuration. Configuring devices, certificate, design. In this, we are going to spend some time in the template section and the policy section. These two places we are going to spend our training session, day number 5, 6, 7, 8. Template and policies. Template we are going to do next session. But policies, after that, we have to learn about policies and all. Then tools is there, that is for operational tasks like SSH the devices, the tag case raging, the template migrations, and all those things we can do. Then we have the maintenance as well. What are the maintenance tasks like software image upgrade, downgrade, security, device reboot, those things. Then administrating task, that administrating the vManage, like creating the cluster, the management of certificates and all those things. Workflows, Cisco has introduced this workflow. This is the new option we have. This option is something that is taken from Cisco DNA, and in the newer versions like 20.14, 15, and maybe upcoming 16, 17, 18, etc., you can go and use this workflow to configure the devices and deploy all those things. They will give you some pre-built templates as well that we can go and utilize those pre-built template like we have in Cisco DNA. But all these packages and configurations are taken from Cisco DNA. Then we have the analytics option. We can go and connect this with some third-party cloud analytic engines, and we can display all those metrics, the parameters within that third-party software. Oh, sorry for that. So that we have. Then SD-WAN portal, you can go to the SD-WAN portal and you can check that. Okay, so this is the overall menu options we have. Obviously, as time progress, we will go to configuration. I'll go to configuration and templates, and then I'll show you. See, we have the template, device template and the feature template. Now for the CCI exam, you have to focus on device template and the feature template. You do not maybe you do not have these options like configuration groups and feature profile. These are some new things that Cisco has added. And again, these are taken from Cisco DNA. And these things, if you do these things, then configuring the devices will become little bit easier than configuring like device template and feature template. Now you can think like this is the older way to configure the devices, and this is the newer way to configure the devices. And at the moment you have all these options, but in future maybe Cisco will go and remove the device template and feature template options. This may be very much in the card that Cisco may go and remove these options in future. Okay, then what we have? We have the obviously the policy thing, which is very interesting. Later on, we will go and learn that we have centralized policy, we have localized policy. These policies we have to go and build. In the lab exam, yeah, you have only centralized policy, hub and spoke, and one is, I think, some application routing policy, etc., etc. So these things are there. As time progresses, we will go and learn more and more about these options. If you have any question, please feel free to ask.
Yes, Ratnesh, actually, I want to ask again for this side ID. So what is the logic behind it?
The
Those
site ID,
different
right?
side.
Site ID is there to group number of same devices. So if
So
site ID
can
is
I
100, mhm.
yeah, sorry. Go ahead.
So if I have two routers in site ID 100, then they are part of site ID 100, and in future when you apply policy, you have to apply policy 100% of time with respect to site ID.
Yes, but from my point of view, the logic of that only between side ID 100 and 200, let's say IPsec tunnel is built is because of inside 100 side ID 100, it should be done via internal protocols, right? So it means that we don't need to build the IPsec between the same side, right?
Okay.
Is it is
So
it
your
correct
question,
understanding that?
I understand your question. Okay, I got your question. So I'll give you one scenario. Suppose, one second, let me draw here. I try to understand. This thing is very interesting. Okay. So I have one location here. Okay. And in this location, I have
Maybe 5 routers or something like that.
some routers, right?
Yeah.
And then I have other location. Let's go here. And here I have also two routers, for example. Now what I want that these two sites do not form IPsec tunnel with each other. What you will do? You create some policy,
Mm,
apply to here, there, blah, blah, right? But if you
yeah.
go and put these devices in site ID 100 and this also site ID 100, they will not form IPsec tunnel.
Mhm.
That is one use case, right?
And in the same site, like let's say first two routers, they should actually exchange some internal
Yeah, they are
routing like
internally connected.
OSPF.
Yeah, they are connected. In our lab, they are connected. Yes. Even we have firewall as well.
So that's why we don't need IPsec tunnels because they are internally connected, right?
Here we don't have IPsec tunnel. Why we need IPsec tunnel?
Yeah. Because we have
Yeah.
internal routing like
IPsec tunnel is there
OSPF or
only in two different
IGRP or
locations.
something.
Yeah. Here we have
Yeah,
IGPs.
sure. So this is the use case when you want to kind of block the communication between different sites. So you put them
Yes.
to the same side ID.
Yeah. Yes.
Okay. Okay, thanks.
Problem.
Is the site ID limited to a physical location, or I can extend my site ID through the WAN, for example?
It is located at physically somewhere. Site ID is logical
Yeah.
number. It's
Yeah.
a grouping of devices and you're putting some ID on that.
Okay. Okay. It's logical. Okay. Good.
It's logically, yes, logical. Feel free to ask if you have any other question.
In that lab environment, we have the access to. Is there any diagram how I can see this structure of the devices, how they are connected?
Diagram is there. I'll show the diagram next class. The document I
Okay.
share with you guys, there is a small lab guide is there and the diagram is there. But I'll show you
Okay.
that
So in
next.
PDF it's there. Okay.
Yes. Yes. Yeah. Okay.
Yeah. Thank you.
All
Yeah,
right. So
okay, good.
guys, let's stop here. We have completed our day number up to 3. Please, I will upload this recording and send you email. So from the drive itself, you can get the recording. I'll put this recording in the same folder where you have the documents so that you can have a look on that. And what we'll do that we will connect next weekend. Okay.
Okay, perfect. Thank you. Thank you
Yes.
very
Thank you very
much.
much.
Thank you.
Okay.
Yeah,
Thanks a lot.
much
Thanks. Bye.
appreciated. Thank you.
Thanks for joining. So today we are inside day number 3 as per our agenda training. And today I'm going to cover these topics. You can see within day number 4, 5, and 6, how to use this template, these feature templates and CLI templates, and how you can go and build, push this configuration from vManage to the devices. So that's the agenda for this particular training for today's session. We quickly go here to the diagram. Yeah. So very much this is the topology, the diagram that we have that we are going to follow. And now you can see that we have one data center and then we have branch 1 and branch 2. So overall we have 1, 2, 3 V edges and we have 2 C edge. So what we are going to do today is that from the vManage, we will go and push the template to one of the branch or maybe one of the data center. I will show you all those things step by step. So let's try to understand the template first. What is template? Why we are using template? That's the first question. So if you go to any Cisco router or switch, and if you go and type show run, then you will get full configuration, right? You will get one big configuration file, and that configuration file having different types of things. So that particular configuration item will have the uh, part 1, part 2. I'll go and write those things. So, for example, it has some host name and basic parameters. Then it has some AAA configuration, some SNMP, some banner, some QoS, some tunnel configuration, some other utility configurations, right? So if you go and write this show run in Cisco router, Cisco switch, you may get these important values right from top to bottom. These values will be available there. Now, what change we have in this Cisco SD-WAN is this, that instead of writing all those code, all those configuration in the format of CLI, we will go and create a small feature template. So what we are doing that instead of writing that, we are creating feature template. For example, feature template for system configuration. Suppose this is system wide configuration, system configuration. Then we are creating the feature template. For example, feature template for AAA, feature template for SNMP, feature template for NTP, feature template for logging, etc., etc. Then we are creating the feature template with respect to, in our case, VPN 0. Then feature template for VPN 0 interface. Then feature template for example, OSPF. Likewise, we are creating the feature template for QoS, some tunnel configuration, some BGP configuration, some OMP, Overlay Management Protocol Configuration. And then finally, you have some feature template related to policy. Now, if you go create all these feature templates, and if you go and club all these feature templates within one giant template, that will be the device configuration template. Right? So all feature templates, when you go and club together in one place, that will become your device template. That is your device configuration template. Now this template that you have, the device configuration template or device template that we have, it may be in the format of CLI template, which is less popular, or it may be in the format of GUI type of template. Like you will go and create n number of feature templates, and once you go and club these n numbers of feature template, then you will get the device template. Okay, so far if you have any query, please feel free to ask.
That's good so far.
So basically, we attach devices only to device template, not to feature template, right?
So come again. What is your question?
We attach devices, actual devices, we attach only to device template, like Cisco routers.
We are attaching to device template. Yes, you're right.
Yes,
Yeah.
yeah, only to this one.
Yeah. So once you have the device template, obviously the device template you will go and attach. So see device DT, you will go and attach with the devices. But this device template having n number of feature templates associated, right? Okay. So creation of this I will show you in a second, and you will understand this. Oops. Let me clean this. So first of all, what we will do here in the lab, I will show you the CLI template. Obviously the device configuration template related to CLI template. And then I will show you the example related to GUI template. Okay. CLI template I will show you, and then I will show you the GUI template. These two examples I will show you. Right?
Can I ask one thing? So this CL template
Mhm.
is basically name for vSmart template, and CLI add-ons template is for the devices, right?
I will explain that part as well.
Okay.
All right. So let's go here. And just a second. Just a second. Just give me 1 second. Someone is pinging me in WhatsApp. Just a second. One second. Just a second. Okay. Let me pause the recording. Just a second, please. Hello. You can hear me?
Yes.
Yeah. So this task is basically actually very easy, and this task that we have is a CLI template another. It will be very easy. Just you have to take proper attention on this. This is not something new that you're learning, because we are doing this configuration for these devices, right, from so many years, right? So this is something that the approach is different. That's the only difference we have. Okay, so I'll show you how to do first of all the CLI template, and then the GUI template. So let me first of all copy the CLI configuration from one of the device. Copy this. Obviously, this is generated from some GUI configuration. Behind the scene, the vManage will convert everything into the GUI part. So what I will do in this, that I will go and remove some of the parts that I don't want for this particular device. So for example, I'll go here and remove the QoS part. At the moment, I don't want this QoS configuration to the devices, to the new template that I want to create. And I don't want this VPN 10, 20, 30, etc., etc. But I need this management IP. So I will remove up to VPN 20, but I will not remove VPN 512. Okay. And then VPN 512 is there. That's okay. The policy visibility are visible. So these things I don't want at the moment. So now you can see that I have one CLI configuration for one of the device, that is DC1, VH1. Normal CLI configurations are actually big, right? And I'll copy this configuration. Let's go back to SD-WAN dashboard where we have the lab. So here we have the lab. Now you can go to configuration and templates and device template. You can see device templates and then CLI template. You can see create template, CLI template option was there. Select the model. So my model is the Edge Cloud. I can go and search as well. It will be there in the bottom, VH Cloud. Then this is for say DC, CLI, device configuration. That's the name, DC CLI config. You can give any description. So now what I can do, I can go and copy paste this configuration here. So options are there. You can go simply copy paste the configuration, or you can see here that we have option select file. So I can save this configuration as some text file and call here, right? I'll click add. So now once you go and click add, that means that you have created the template. Now the template that we have created here is, so let me quickly go and mark here. So the template that we have created here is DC CLI device config. The description is DC CLI config. The type is CLI. This is for device model vHCloud, right? So this we have created. But is this template attached with any device? No, because otherwise it will show you some 1 or 2, 0. So now what we will do, that we will go here and attach this to DC1 VH1, suppose. So select and use this, move to other side, select and move, click attach. Now once you are in this page, this is very interesting page. You can select the device. Once you select the device, and if you want to see the difference in between the running configuration and the configuration that you want to push, right? So that difference you can go and check. So you can check the configuration preview. You can check the, change the color. You can check the conf difference, and you can see here the side by side difference. So now if I go there and click side by side the difference, it will tell you that earlier what configuration was there and now what configurations are there and what we are removing. So all parts, so all red one is missing on other side that we want to configure. Now click configure device. Now you can see on top it is in progress. Validation successful. Now the configuration push. So what is the order of operation? The order of operation is this, that you are creating the template at vManage. So we are creating some CLI template at the level of vManage. vManage is connected with the edge devices via which protocol? Via DTLS tunnel is there, encrypted tunnel is there. Now within this tunnel, they will go and use one protocol called Netconf, and it will push the configuration via the Netconf protocol to this particular device. Okay. Is this understanding is okay?
Yeah, good so far. Yeah.
All right, great.
Okay.
So now this is the
But
CLI.
just one comment. So in this kind of template I create, even though I can attach it to multiple devices, well, the parameters are specific, like the IP addresses, etc. They will be the same, right?
Yeah.
If I
So I'll
attach
answer
to
your
multiple
question.
devices.
Yeah. So I'm coming to that. So now what we have done, that we created the template, one template we created, and that template we have attached with one of the device. This is CLI based template. So I connected with VH1, suppose, and now suppose I have to connect the same template. So suppose I have this template connected with this, and I want to connect the same template with this. So it will work, it will not work, right? Because the IP addresses, the parameters that we have, they are very much fixed. So, but if I go and create variables related to system IP, see, system IP will be different. Maybe site ID will be same, that is global value, but system IP will be different. Then if you go to the interfaces, if I go to interfaces, the IP addresses over the interfaces are different, right? So how we can go and create a generic type of template, uh, template with variables that will go and attach with multiple devices. So one template can be get attached to multiple devices. How we can go and achieve that task? That is the next thing that we want to solve. Okay.
Okay, good.
So how we can achieve that? So let's see, first of all, we will see the variation in the CLI template itself. So let's go back to the CLI template that we have, configuration and templates, device template. Already we created one CLI template. Now you can see it is attached with this particular device. You can click and see which device is this. This is the device which is connected. So now what we'll do, we'll go here, click these three dots and click edit. And now this we can make as a variable. So if you go and select this system IP like this, select it. And here you will see there is one button, create variables. So if you select and click create variables, it will ask you that what is your variable name. So I'll go and give, say, I'll use anything today, today system variable, create variable. So now you will see it will be within the parenthesis because I haven't clicked properly. Create variable, say today's system var, create variable. So now you can see again, if I go down here and if I go and change the interface, you can see internet IP, just to make this variable. I'll rename it that today's inet IP. I'm not clicking actually properly. That's why it is not taking it. Let me do it again. So inet IP, and then you have to click here, create variable. Then this will get changed. And likewise, you can go and select n number of things and create it, right? Now, since this is one attached template, so if I do any modification, then it will ask this thing in the configuration itself. So now you can see that it is asking me, oh, you are doing some update, right? So can you provide me those information? So that's why the status is amber here. It should be green. If everything is okay, you should see green color here. Then you will see that system variable is missing, system IP is missing. These values we have to go and put. Why? Because now we have made them as a variable. They are the variable. Now they are the variable. So that means that this template can go and use in different devices, but those devices we should know how many variables we have. Otherwise it will be miss. So now what we can do, see multiple options are here. So once you reach to this point here, you have multiple option. The industry standard approach is this what? That we have some, actually we are downloading the CSV file. So if you go and download this, you will get one CSV file. In that CSV file, you will go and put the system variable and internet IP, and then you will upload. So you will do the download and do the upload. Okay.
So
So
this
it
is
will,
per device, right?
yeah, device. You
So
can
we need
download.
to go
Mhm.
to each and every device and define those variables.
Yeah. So what is happening that you have different locations, right? So when we are talking about this SD-WAN fabric, so we know that different locations are under different managers. So different areas are there where you have different network engineers. Means if it is a big branch, then you may have 10-15 engineers at that branch. If it is a small branch, then you have 2-3 local engineers. Now, local engineers, they know what is the site ID, what is the system IP, what is the public IP, what is the private IP, etc., etc. So anyways, they are maintaining it either in Excel or you have some central IPAM where you are managing the IP addresses. So point here is this, that these configurations that suppose if I am in small network, that's okay. Anyways, a small network will not use Cisco SD-WAN. This is suited for enterprise network where you have 50 branches, 100 branches, 200 branches, 400 branches, right? So these branches, obviously, if you have branches, then there you have branch manager. Under that branch manager, that business is running, right? So he has full control about his IP addresses and site ID and blah blah all those things, because you know how things are happening in companies. You have to take permission and this. So what is happening, that the engineer that is sitting in data center or HQ location, he is emailing these CSV files to those engineers. Now those engineers, what they have to do when they are onboarding the devices, simply they have to go and upload these files and then put the variables. That's it. That's the reason the approach, this type of approach Cisco is using. Got my point?
But this approach is not very common, right?
This approach is common, yes. In SD-WAN, this is common approach. We are uploading the CSV file and people are
I mean,
maintaining this.
for to define it with CLI device template.
CLI we are not using actually.
Yeah.
This is just for learning purpose. We are
Yeah.
going to use the feature template. But since we should know, means this is one option we should know. So that's why I'm explaining this.
Sure. Thanks.
Okay. Now, the task that we are doing here, this task you have to do in the GUI template as well. So in GUI template, how we are creating the variables and all, I'll come to that point. Let's go step by step. I'll come there in next 15 minutes. So let me quickly go and delete this. So what we need here, we need the variables here. So I can go and double click here and assign the variables, or even you can click these three dots, edit device template. Once you click edit device template, it will ask you what's the system variable, system variable. System IP, right? That was system IP 10101. And what is the internet IP facing? So let's see the configuration. I don't know what is that internet facing IP. This is MPLS and this is internet facing IP. Update. Now you can see it's become green. Now click next, next, next. And we'll wait. Now, by any chance, if I put the MPLS IP and the internet IP same, then it will show you some conflict message. It will tell you clearly in this log that, hey, your internet facing interface IP and your MPLS facing IP, they are the same. It will tell you that change it. Validation successful. That means we are good. And the configuration is CLI template with variable is working fine. Okay, so you can see here that it is working fine. Any doubt? Please feel free to ask.
All good. Thanks.
Okay, let me quickly pause the recording one more time. So what we have done just now, that we just completed the CLI based template, and that CLI based template that we have completed, we have variation in that CLI based template. The variation was that we use variable as well within the template, although I haven't attached to different devices, but I have shown you the variable option is there. Now this variable option is not a unique thing. Sometimes we are telling this as a placeholders or in programming language. This is not a unique thing. This is something there in already there in programming languages. Now this is introduced to Cisco devices or other SD-WAN devices. Introduction is new, but this is old technology that we are using. Now the variable that we are using, the variable that we are using, it may be of three types. And again, this is purely taken from programming world. The variable may be local variable. You know, in programming, we are defining one main function, And in main function, you have function 1, function 2, function 3, and n number of functions. Now here also what they have done, that they have the device configuration template you can think as a main function. And then you have feature template 1, feature template 2, and n number of feature template. N number of feature template means that you have feature templates for different tasks. Feature template for OSPF, BGP, OMP, VPN0, VPN0 interfaces, login, NTP, banner, blah, 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 right? Like that, when you are doing programming, you are creating functions within the program to make that program as a modular program. Your function is like your program is modular. Now from this modular, nowadays, nowadays, the houses are also modular. Now we have concept of modular kitchen. What does it mean? So different pieces within the kitchen you have in different modules, right? Modular. Like if you see the concept of shopping malls, shopping malls, big mall is there, and then you have different things, right? Yeah, like you have different things that you can purchase in one location, etc., etc. But point here is this, that you have one big template. Everything is taken from this programming world itself. It's not like uh, multi-tenancy and whatever things are there. It's a new concept. If you go and check the multi-tenancy also, like tenant within tenant and all, it's logical separation. Logically you have separated the things to do different tasks. That's the main concept here, that logically you are separating different units, and if you go and club all these units, then they will become one unit, right? So here you have this. Now who will provide the power to these feature templates and all? So power will come from the variable generation. The variable that we are generating, it may be local variable, it may be global variable, or it may be default. Only these three categories are there while we are defining the variables in SD-WAN. Local variable means what? Local variables means that within the function. Global variable means what? Global variable means that from function 1 up to function n, it will be fixed, right? And default is default, like it's a default configuration, neither local, not, it may be local, it may be global, but it is default. You don't have to worry about that. Now, if you understand this concept, you will understand the device template concept. This is the main thing. If you have any doubt in this, you please feel free to ask.
Why we need a default variable?
It's not a default variable, it's a default system generated things, default.
Okay. Okay.
Yeah. Like if you go to Cisco, and if you type show running configuration, you will get to running configuration, right? And then you have one option, show running configuration all or show running configuration full. Then you will get extra 1000 line. Those are some default configurations, right?
Okay. Thanks.
All right. So what we will do now, that we will go and use this concept, right? And we'll create the template and device template. So let's do it together. So now what I will do, that the same configuration, you can see the CLI configuration. I'll show you one trick here, that CLI configuration, even if you go and check the CLI, this is system-wide configuration, right? So this system-wide configuration that I have, and then you will see that we have the AAA configuration. So the AAA configuration that we have, then you can see the logging configuration. So all these CLI configuration that you are seeing here, what we can do, that we can create template for this. This is the CLI configuration, but now what we want to do, that we'll go and create the templates for NTP, right? templates for security, but important one is this, to create the template for VPN0 interface, right? So these things will do. Let's do this together. Now I can come here to my, oops, vManage. And once you're here, you can go to configuration. So approach is there that either you can go to feature template, create different feature templates, and from that you can create the device template. So I will use that approach. I'll create first feature templates. To cloud and see. First of all, what we have the system-wide configuration. And say today system. Now you will see the good part here is this, that you can see different options. Cisco, what they have done, they have already given you the variable option. This symbol is for variable. So my variable name is system ID. My system IP is variable whose name is this. And this symbol is for default. This is for default. This is for variable. This is for default, and likewise.
So this first symbol is for device specific, right?
Device is specific. This is local variable, yes. Then if I scroll down, this is global.
Mhm.
I should put some value here. Suppose I'll go and put any random value. Then you can see default values are there. So this default configuration will very much work because it already have the variables as well. So then I created one. Now if you come to last update and click here twice, 1, 2, then you can see your template. Likewise, I will go and create the other template. So now this time I'll go and create AAA. I don't have a specific AAA servers and all. So what I will do here, that this also I will go and use all the default values and the parameters. So see, AAA, you should have the AAA server is radius or tachus. All those informations you can fill. If you know that, you can go and fill it. It's like knowing the CLI configuration. If you know the CLI, how you can do in CLI, here you can go and do it. So this also, we don't have a specific AAA server, so I will use it as it is.
It would be
Yeah.
actually nice if there is some option to export this GUI template from CLI, that you don't have to fill it manually.
Means all these templates you can see already, best configuration is there by default. Simply you have to go and add some values. So for example, BFD. A BFD, all the best known configurations are already there. You don't have to worry about how BFD will work and all. If you have some specific changes, you can go and use it. Otherwise, there are default system BFD configurations are also there that we can use. So what I'm telling here is this, that I can go here And this time, suppose if I have to go and create the template for NTP, I will use some system default. OMP, I can go and use some system default. Security, I can use some system default. Those are also configured. Best known configuration is there in that. Okay, and so we have done this part. Let's go down here. And if you go down, now you can see very important options here related to different things. And see VPN. So here I'll put one marker when you are coming to VPN. Remember this thing. VPN either 0 to any number of VPN, the VPN 0 or VPN 512 or any VPN. So VPN 0 configuration and interfaces under VPN. Say VPN interface 1, VPN interface 2. They are different templates. So for VPN 0, you have to create different template. And for VPN interface, you have to create different template. Be careful about that. For VPN, you have different template. And for VPN interfaces, you have different template.
And for service VPN?
Same is for service VPN.
So this is also for
VPN 10,
1
you have
to
to create different template.
511.
Yeah, and VPN interfaces under VPN, you have to create. So VPN interface. It's not 1, 0 and this 0 up to 512. Whatever interface to. Okay. So VPN template is different and VPN interface template is different. Clear? Okay, so let's do that. So first of all, we'll go and do the VPN configuration. Now, if you do VPN configuration, under VPN, you may have n number of interfaces, right? So if you see the VPN here, VPN configuration, under VPN, I have these things. And then under VPN, I have some routes as well. You got my point? So under VPN 0, if I remove these interfaces, under VPN 0, you have these many items that you want to add in this case. Then under VPN 512, you have to add these many. I'll come to that. Let's focus on VPN 0. Under VPN 0, these many things we have to add.
So under VPN 0, there is global routing for the routes, right? Also
Yeah,
for
default routing.
management. For
Yeah.
service VPN, it would be in VRF.
For
The
service
default
VPN, yeah. So VRF, yes, yeah, right, yeah. Service VPNs are nothing but basically they are the VRF, right? Okay, any doubts so far? Clear?
Yeah, clear so far. Good.
All right. So let's continue and let's create the VPN 0 template together. I can come here. And system VPN 0. All right. So now if you are here, you can see VPN global value is 0. That's okay. That we want. Then leave the system settings and all this. It's very tricky. VPN DNS, primary DNS address. So I can go here and make this global. What's the primary and secondary DNS? Moment you put primary. Now see, this is the default, none. But I'll go and make this as primary and secondary, maybe 1.1. Right? Any doubt? Okay, Vugar, you're there? I got your message. All these sessions are recorded and uploaded to the shared drive. I already shared the
Look,
link.
it's okay.
Link is already shared, but anyways, I will share you via WhatsApp as well, over the WhatsApp as well. Okay.
Okay, thanks.
All right. Thank you. So you can see that we are putting this DNS value. Now, once you put this DNS value, after that, we have this DNS entry for vBond as well, the vbond.cisco.com. So for that, I should go ahead and click new host mapping. What's the host name? So vbond.cisco.com. And then the list of IPs for vBond, 11 and 21. So list of IP 11 and 21, right? With comma separation, I can click add. Okay. Now let's go back. So what other thing you want to add? You have to go and add the static route, this default route actually for internet and MPLS. So for that, let's go here. If you scroll down, in case you have to advertise OMP, you can use it. You have to create some aggregate. You can use this aggregate. Now we have to go and create the IPv4 route, default route. So click this IPv4 route, scroll little bit down. You have to give the prefix is 0000/0, and then we have to add the next hop. In our case, we have to add 2 next hops. So I'll click add next hop and I'll make this variable. So next hop I will make variable and I'll change the variable name. Suppose this is for internet, INET. Oops, ET.
And how does it know which next hop it will use for?
We have to provide that.
I
It
mean,
will not
there are
know.
two. So one is for MPLS and one is for internet. So
Yes, so you will see that how it will know that because
okay.
we have to provide it. So it's a default, right? So 1221 is the same. Anyways, we have to provide it. I'll show you that how it will come to know. I'll come to that. See, if you scroll here, you can see that it is for internet that we want to put, and this is for MPLS we want to put. Click add first, add here, and then second add here. So you will see this line here.
Okay.
So what we have done here that we are very much good up to this point. That means we have created VPN 0 template successfully. Click save. How many templates we have created today? Click last used 2 times. System VPN 0, today BFD, today AAA, today system, like that we have created. Now what we want to do that we want to create 2 more interfaces for under VPN 0. So we'll go to VPN interface Ethernet. Click here. Will come. So that. Say today VPN 0 internet. Suppose this is for internet I'm creating. Now interesting things here. That basic configuration shutdown default is by default it is shutdown. I want to make this no shutdown. So globally I'm making this no shutdown. Interface name, do you know interface name? If you know that interface name, you can go and put it. Otherwise you can make it as a variable. Since I know that, I'll not make this complicated. So for the internet, we have gigabit Ethernet 02. So I'll come here, gigabit Ethernet 0/2, double confirm, yes. If you want, you can put the description. Then IPv4 address, you know the IPv4 address? Yes, I know, but I'll make this as a variable. Okay, then let's see what other things we have. So interface name, IP address, then full tunnel configuration. So we'll go here back, and once you are here at the tunnel, by default tunnel will be off. Turn this tunnel on. Once you make this tunnel on, you will see tons of options are there. So what is the color? The color here is, we are in this part, biz internet restrict. What does it mean by restrict? Restrict means that suppose you have your SD-WAN devices and you have two ISP. ISP blue, ISP red. So by default, we know that SD-WAN devices, they try to form IPsec tunnel over different ISPs, right? Because that's the nature of SD-WAN, that they always try to build the tunnel over different ISPs, right? Always they try to do that, right? So if you go and use the keyword called restrict, so in that case, MPLS will always form tunnel only with MPLS color, and internet will always form the tunnel only with internet color. Same color will form the tunnel. Otherwise, if restrict will not use, then they can also form the tunnel. Okay, so that's why we have the restrict keyword.
Yeah, so by default, the tunnel creations are full mesh.
Full mesh by default,
Mm,
yes.
Okay.
By default is full mesh, yes, you're right. All right, great, good job. So now let's do that. So I'll come here and make this global. I know because this color is internet. Restrict is on. Rest things, by default you can leave it. Save this. Now, since we have one template that we have created, and now we have to go and create one more template for internet, you have this option that you can go to this particular template and you can create one copy. So I can go and create one copy. Once you create the copy, just rename it. VPN 0, say MPLS this time. VPN 0 MPLS, but we have to go and change that values because values are put as per internet. So now we'll go there, click edit. Interface, what is the interface name? Let's see. Interface is gig01 for MPLS. Shutdown is no. This variable name, I'll make this as a MPLS. Rest, oh, color should be
MPLS.
PLS. Rest parameters are the same. Click update. So now what we have done that we have created, how many templates? Let's see. One, one more time. 1, 2, 3, 4, 5, 6. At least 6 templates we have created. And then we are going to use some default template as well. So if you are here in the feature template place, you can see non-default templates. This that someone has created. Then you can see that default is also there. System generated is also there. System generated templates are there. Cisco are giving. Leave that. Non-default templates are there that if you want to create your BFT template, so what you do, simply go here, copy this. And instead of this name, just give say today BFD. So now it's already there because I have created earlier. Today say BFD2. So now you have template for BFD as well, but as a non-default template. So if I click here twice, you can see BFD2. Earlier I have created BFD, so that's why it was showing. But now you can see that we have BFD2 as well, right? So now we have all these items. What we can do that we can go and club these items together. So we have good amount of feature templates, FTs. Now we will go and club all these FTs into the device template. So you can go and click here to device template. This is the place you can click. Once you click, then you come to this place, right? And this time what we have to do that we have to go and create a from feature template. Create template from feature template. So click that. Now once you do that, you should go and select the device model. In our case, the device model is the vEdge device role is this. It's a template name. Template name is say today DC vEdge template.
So this is for VH1?
This can be used for one and two both.
Okay.
This for DC because we have enough variable there. So we will attach this to both. I'll show you that how we can do that. Okay, so once we are here now, then we can go and add the system that we created, today's system. Logging, if you do not have, we can go and use the factory default. I can click NTP here if we have NTP. You can create it. Otherwise, you can see that we can create NTP from here as well. So I can go and create the template for NTP. Say today NTP. Save. So automatically it will get populated here, right? Then AAA. Yes, I have AAA. I have OMP. I'll take some earlier created template within this. BFD, I can use some today BFD. Security can use factory default, no problem on that. Then we'll scroll down and come to this VPN section. So for VPN 0, we have created one template, system VPN 0 that we have created. Then for VPN 0, internet and MPLS. So we can select this internet and then add VPN interface. Click here to add VPN interface. Likewise, I have not created for VPN 512. I should create for VPN 512 as well. So no problem, we can create from here as well. Click
But this should not be feature template.
feature template. This is feature template.
But now it's showing device template up there.
Under device template.
Okay.
I'll
Oh,
show
okay,
you
I
that.
see now.
Yeah.
It's in that corner
Today,
on the left
VPN.
side.
Yeah. VPN 512. So the global value is this. And what are the things we have in VPN 512? So VPN 512, since this is don't have tunnel and all, only you have to provide the IP route and the gateway. So this gateway is actually common. So I'll use this value. A straightforward can be used. And let's go back. So simply I need IPv4 route. One is static route I need. So 0, 0, 0, 0, /0 and then only one next hop. And that next hop value also I will go and put some global value, not a variable. This is a fixed value. Add and save. Once you click save, then your VPN 512 is Done. You can click here. You can see your VPN 512 template, but we need interface within this. So we need one more template here for under VPN 512. So now we'll go there. Say today VPN 512 interface. VPN 512. Shutdown should be no shutdown. What's the interface name? Ethernet 0. What's the IP? I can make this IP because this IP will change to all the devices. So I'll make this as a variable. But the interface is ETH0, Ethernet 0. I don't know, it's a 0 or 0/0. It's a ETH0. Okay. Then shutdown. No, that's great. Then the IPv4 address. I'll make this as a variable. And this variable name I'll specify here. This IP address for VPN 512. I think that's it. We can save it. And now we can go and click create the template. Although there are so many different things like policy and all. Yes, let's create this. Now we have one DC template, DC device template, that is the GUI based template. This one. It is using 12 feature templates, right? And it is not attached with anything. We haven't attached anything. This is SD-WAN edge role. Okay, so let's do the attachment. So now if you go here, click attach devices, DC1 VH1, click attach. See, it will ask you all the values, right? All the values it will ask you to fill in. So what are the values you should put here? Say, now you are asking, right? Say how I'll come to know what is the thing. See, even if you write the variable name or do not write, if you go and just scroll here, it will tell you what exactly it is looking for. So you can see that VPN 0 IP route. This is the next hop IP address for internet, right? You can see clearly. So let's put this values one by one. IPv4 address for VPN 512. Ethernet 0 interface IP address. What is that?
Ethernet 0.
Ethernet 0 IP, right? So we'll go and put that IPv4 for Ethernet 0. Then it is asking for the next hop for internet and next hop for MPLS. So I don't know which is internet and which is MPLS. So let's see. Internet is 2.25. This below one is internet. So this is for MPLS. Next hop. And this is for internet. Then it is asking IPv4 address over MPLS. So for MPLS, IPv4 address will be /24. I'll check that. Internet may be 20. Let's verify this. So internet IP is 26/30 or /30. This is a point-to-point address. 26/30, and this will be 30. Host name. New. I'll just change this. DC1 VH1. I made this new DC1 VH1. System IP I know that is 10.1.0.1. Site ID is 100. Right? So we are putting all these values. Click update. Now it is green. Click next. Configure it.
Actually, I don't understand why we need to put hostname and side ID because it's up there already. It was there before.
Yeah, it was variable in the template.
Okay.
Failure. See, that is good. Failure. So once it will get failed, then we'll come to know why it is failed, right? And we can troubleshoot. So what it is telling, an element value is not correct VPN instance. So what it is telling, delete ETH0 from management. So the value that we have, we were checking earlier that is it correct? So if you go to this show run interface VPN 512, show run VPN 512, ETH0. Interface name is ETH0. Wow. Let's see. Template. We will search and we'll fix. We'll go to feature template. Now what I want to search here, that's why I have made all the template starting with today. So I can search with the template today. And sometimes they are telling that you use some keyword CCI. You know why? Because you can search your template with that keyword. I use today, there you can use some other name, right? So with today
That's a
I can
good
go,
trick.
yeah, I can go and search the VPN 512 interface here, and I can edit this. ETH0. Or even I can make this also variable.
So if it's with capital E, it would be mistake.
Yeah, because in the CLI it is showing this thing.
Okay.
Let me see one more time. Yeah, it's showing like this. That's why it is throwing error. Anyways, now we'll come to know about that part. So now let's go back here. Attach the device. Need to do that exercise one more time. That's why you can put all these in CSV and upload in single shot. Okay. Let's swap addresses. Internet. Oh, it is taking it. That's great. Is something wrong there? I'll correct that.
It's actually IPv4 address, not the next hop. So you need to put the IP address of the interface.
Yep. And what about the internet address? Oh, 6/30, I think. Okay, so now we are good. Let me quickly double check. Okay, it's 100, right? You're telling it's right. It's 100. Okay, next hop, anyways, that value is global. So now let's go next. Next. Let's see. So if the push is green, and then it should be configured green. Again, we have failure. Wow. Next 2 times we have failure. What is that? So what it is, a gigabit Ethernet 0/1. Name length exceed allowed 16. Interface name gigabit Ethernet 0/1. What is that interface? God, you can see all
It's weird.
interface. all interface naming issues we are getting. So,
Okay.
this is the VS device where interface name is like this. But
Mhm.
in CH you have to write like gigabit Ethernet 0/1 0/2 0/ blah blah blah.
Yeah,
Right?
it's even coming from that drop-down menu, right? So it's
Yeah.
automatically populated. So it's strange that it's not matching.
Yeah. So never mind. I'll go and correct it. Now I have to go two places and correct it. So I'll do that. 0/1 is for MPLS. So let's go back. Now I have to go to feature template one more time. And once I am here in inside the feature template, then I can go and click 2 times here and VPN 0 interface internet. Or that internet facing interface is 02. Let me choose this drop down menu. And I do not see that. Anyways, you can see what are the things happening, right?
Yeah.
Then 1
Yeah.
and 2. But this thing you
So
can't afford in exam. You have to 100% sure because we don't
yeah,
have time in the exams. Okay, and then where is that MPLS today? MPLS, here it is. It
that's the thing that here in the feature template it will not show any error because it doesn't know to which device you are going to apply it later, right?
Yeah, that's right. Attach the devices. Third time, let's see. In all these values. And this time it will be easier because we have all those things. Okay. MPLS IP is 2/3.
Why didn't save those two only?
Some Chrome issue or something.
Okay.
6/30. Now, if we are lucky, then it will push the configuration.
Yeah, I did.
Wow.
Yeah, all good.
That time we are lucky. So let's go back here, and this device, you can see the device name will get changed, right? And but you can see that how we can push the template. Now what we'll do, let me go to this device. Show run VPN 0 and show run VPN 5. This template that we have created, now the same template we will go and attach to the other device also. Since we have make the variable template, so it should work. So let's go there. You can see that DCV edges, now it has only one device attached. Why? Because one we have moved to other template. So now I will go here and attach. Even you can detach and attach, right? But simply if you attach also, so it will take. So now I'll go to branch 2 vh1 and push here, click attach. It will ask you all those parameters, all those values. Wow. This is something that it has all the other things as well, like VPN 10, 20, etc., etc. So let me do one thing. I have to. Okay, let me do one thing. Let me do. This do not have same type of configuration. Actually, it has different configuration. Detach it. Let me detach and try to attach. But you know, right, that how we can do these things, right? All these steps you can see.
Yeah, it's
Yeah.
clear.
For this device model, when we are choosing, can we choose more device models?
Yeah, yeah. Yes,
Okay.
yes. You can have good amount of device models like A, B, C, D, E, F.
Mhm.
One template can be for different devices. Yes, you can do it. That's the flexibility we have. In
Yeah, and
production, if you Mhm.
no, I was about to say, yeah, and in production, there is like a pre-work to do to structure your site and variables. Then after you have done your template, I think it will become easier to apply to any device.
Of course. Yes.
Yeah, you can even choose all the models to make it more like easier.
Yeah.
Yeah.
I agreed. This is just, that you can understand, like I will not make things complicated, but this is the way we are doing. So where is that?
And when you attach the template, the config that it pushes, it's add on the existing configuration, right?
Yes, yeah.
Yeah. Okay.
So it will go and remove all the old configuration and it will put all the new configuration.
Yeah.
Now you can see. So let's put these values. At the moment I'm putting it, I'll change it. This is the correct branch. Yes. 10.1.0.2.
So branch 2 is also site ID 100?
This is DC.
This is DC
Yeah, this is
because you
DC.
have the name branch 2.
Yeah, I'll rename it. This is DC
Okay.
actually. Right, this is DC, right?
Yeah, you just copied the
Okay.
branch 2 template. Okay.
Yes, got confused. Let me cancel and go back one time. Okay, so what
By
I
the way,
want here,
swap, it's only for 5 days each time. So if you create those templates, it will disappear after 5 days and you will lose everything, just to remind you.
all templates are already there. This is our class
Yeah,
work.
but if you create some new templates, it will disappear after those 5 days.
Yeah, because the lab will get reset after 5 days.
Mhm.
Yes, you're right. Yes.
Is there any way how to save those templates in some, like export them?
We can do that via automation. You need one Saster tool. Let me do this and I'll show that after that.
Okay, sure.
Attach to the CVS template. I think this is the template we are using, right? And by a mistake, I choose this upper one, I think. Okay, sorry for that. DC1 BH2 should be there. Okay. Mhm. Okay, so this is correct. This is correct. This I'll make as today. This IPs I need to check. So this should be 30. That's correct. This is correct. I think the gateways are the same. And this IP seems wrong. So what is the IP? Let me quickly check. For management 101. Okay. Should be 101. So rest parameters are correct. Circling, it is moving. Wait. Go ahead meanwhile. And if the name will get changed, that means push is successful. So now you can see, say same template we have attached to two places. Now coming back to your question. You're asking how to take backup for configuration, and also what you need to do, you can go to GitHub. Sastre is one tool to take configuration backup from SD-WAN. You need to clone this repository, and then you can take the backup. Whatever you configure, you will take the backup for everything. And then you can upload, like, take the backup and then upload the
Next time.
configuration the next
Okay.
time. Only thing it will not do, you have to reattach, but your configuration will be there.
Mhm.
Okay, you can use this Sastre tool.
So in SD-WAN itself, there is no option to do some export and save it in some, let's say, XML or something like that, right?
That is not there. We have to use some tool, yeah, external
Okay,
tool.
sure. Okay, thanks.
Okay, great. So we have completed the task. That's good job. Let me quickly see where we are now. So we are doing good. Actually, our progress is good. We have completed day 1, 2, 3, 4, 5, 6, up to day 5 actually, and 6 also. So we have completed up to this. Next class, I am going to cover day 7, 8, 7 and 8, only these two. And if time permits, then I'll give you a little bit introduction. So I will cover this also. These many topics I'm going to cover next class.
So
Day
you mean
number 7,
tomorrow?
8, and 9 tomorrow. Yes. Day
Okay.
number 7, 8, and 9. Okay.
Yeah,
Hi everyone, thanks for joining. Today we are in day number 3 as per our bootcamp. We have 2 more days left, means next class and next class. If it is extended, then 3 more classes after this. But I'll try to finish up all these concepts within next 2 classes, means next weekend. All right, so what we have to work on in today's session is to understand OMP and TLOC, and then we have follow-up lab related to that. So let me first of all explain you about this OMP thing, how it is working, what exactly this is. Now here you can see this is very busy diagram. Um, not like this. Let me go and draw something new, fresh. Here it is. So let's try to understand OMP. You can see my screen, right? Abdul, Tony, you
Yeah,
guys are
we
there?
can see it.
All right. So we have DC and we have two branches, branch 1 and branch 2. Now in these locations, we have few edge devices, C edge, V edge, whatever branch edge devices are there. And then we have certain ISPs, ISP red and ISP blue. Okay, ISP red, ISP blue. Uh, now it's very interesting. If you understand this thing that I'm going to draw, then you will fully understand about OMP and TLOC. So let me complete my diagram. This is your router. Suppose this is your router number 1. This is your router number 2. And then obviously you have your LAN network. With your service side VPN, your LAN network is connected. And somewhere you may have firewall, somewhere you have a DNS servers, somewhere you have some applications, etc., etc. Then you have your connectivity with ISP, like this. You have your connectivity with ISP. That's the logical connection I'm putting here, some connectivity with the ISP. Now for these branches also, say this is branch number 1. There also you have some LAN network connectivity. Maybe you have LAN and maybe you have some router also connected below, service side VPN. Then you have your router here and then you have your LAN connected with service side VPN. Right. So in day 1, we study about one thing about mandatory configurations. So you should have the host name, site ID. You should have the system IP, site ID, I and D, system IP. You should have the reachability to vBond and you should have the organization name. The site ID, suppose this site ID is 100, this site ID is 200, and this site ID is, for example, 300, right? Then what about the system IP? So suppose this device having system IP 10.1.0.1, this having IP 10.1.0.2. This having system IP, suppose 10.3.0.1, and this having system IP 10.3.0.2. This having system IP 10.4.0.1. So likewise, you have the system IPs, right? Okay, problem. So we have the site ID, we have the system IP. Now, what's the use of system IP? The system IP we have, there is one terminology in Cisco SD-WAN. That terminology is nothing but TLOC. TLOC is nothing but transport locator. T for transport and LOC for location, locator. It's a mix of different things that SD-WAN creators they have done. In normal in IWAN, intelligent WAN, we have something called LISP protocol, LISP, location separation protocol that we are using. And in LISP, we have some sort of mapping server. We have some sort of, MR, MC, etc., like controllers and servers. And there we have some RID, router locators. From there they have taken these concepts of TLOC and all. Somehow they have managed to create it. But make this simple. This TLOC is nothing but, so very much like next hop type of BGP attribute. It's a very much like BGP next hop attribute. This TLOC, transport locator. And what is the location where they are situated? So the location for these transport locators are here. This is the location of transport locator. And these transport locators, they are having three major attributes. They have so many attributes, but they have three major attributes. What are those three major attributes? So they have attribute. So this TLOC having attribute system IP, color, and encapsulation. Sys IP, color, and encapsulation. System IP, color, and encapsulation is the attribute for this. Okay. Now, if I have to go and write the TLOC locator for branch 1, suppose this is branch 1, PR1, CH1, and this is branch 1, CH2, CH1 and CH2. This is suppose branch 2, CH or VH1 or 2. So if I have to go and write the transport locator for this particular router, what will be the transport locator for this? I know that transport locator for branch 1 CH1 will be the system IP. What is the system IP? 10.3.0.1. What's the color? So if it is connected with red ISP, so color will be red. And what will be the encapsulation? Encapsulation, mostly it will be IPsec, because you want to form the IPsec tunnel. But we have option for encapsulation at GRE as well. But mostly it will be IPsec. Now, if the interface is going towards this direction, suppose in this case, I don't have interface going to this ISP. But what about branch 1 CH2? What will be the TLOC? What will be the TLOC here? So TLOC will be the system IP, that is 10.3.0.2. And what will be the color where it is connected? Blue, right? So color will be blue. And what will be the encapsulation? IPsec. Right? Now what about this router? In this router, you can see two connectivities are there. So for this connection, the TLOC will be 10.4.0.1. What is the color? Blue. What is the encapsulation? IPsec. What about this? This will be the 10.4.0.1. What will be the color? Red, right? It is connected with the red ISP and encapsulation IPsec. Now, first of all, you are able to understand this combination, three attribute combination, system IP, color, and encapsulation.
Yeah, good so far.
Okay, so just for this interface, what will be the TLOC?
So
System
10,
IP, yeah,
yeah, system IP.
color is
Dot
blue,
2, color blue.
yeah,
Encapsulation IPsec.
100% right, right? Now, once you understand this concept, right, then the next concept, understanding the next concept will be easy. So we know that somewhere down the line, we have vSmart, right? And that vSmart that we have, suppose somewhere we have vSmart. vSmart is working as a router reflector, BGP router reflector. So that means that suppose in branch 1, you have one network. In branch 1, suppose I have one network X. And X means X equal to, suppose 10.5.1.0/24. For example, I have one X network, and that this X network wants to reach to Y. Y is 10.10.6.1.0. So how this X and Y will exchange their network to each other. How it will happen? So that means that the X network that we have, first of all, it will get advertised from this device to VSmart, and from VH or CH, from this branch device to VSmart, what is the running protocol? OMP.
Okay.
So that means OMP will carry the X. So once the vSmart will learn X network, how vSmart will come to know that it is coming from blue ISP or it is coming from red ISP?
Looking inside the TLOC.
TLOC, yeah. So whenever vSmart will receive any prefix, it should be connected with TLOC. I'll write TLOC 1 here. Suppose this is TLOC 1, this is TLOC 1, and this is TLOC 2. So vSmart will see, oh, X network coming from TLOC 1, that is the red ISP. So that means I can learn this from the red ISP, right? Likewise, this will also connect it. So here also we have OMP connection. And this will also send OMP update. This is also OMP update. So now he will learn Y as well. Suppose some TLOC 3. Okay. And what's the role of vSmart? Is working as a route reflector. So that means that it will go, and when it will send the update, when vSmart will send OMP update, with OMP update, it will send Y. With OMP update, it will send X.
X.
So this way, the route exchange will happen. Okay.
Okay,
So,
good.
So here, one very good question here, interesting thing related to OMP. So OMP, they are learning 3 different type of routes. OMP can go and learn 3 different types of route. One is, so let's see here what type of routes we have. So if you go and split this particular network, you will come to know that different types of route that we have. We have one route that is LAN related. So all cross mark that I'm putting here is LAN network, LAN route. They are nothing but service side VPN route, right? I'll mark this as 1. Let me choose the, okay, suppose this is 1, type 1. Then you can see the TLOCs. You can see these TLOCs, right? TLOCs, TLOCs, TLOCs. So these TLOCs are 2. And then here you will see that we have connected one firewall as well. So vSmart should know the location of firewall as well. That will be 3. So these 3 different types of routes that OMP is knowing. OMP is knowing, first of all, service side VPN route. All this XXXX is service side VPN, service side VPN, service side VPN. Then it is knowing the TLOC routes. All the next hop gateways vSmart should know. Then finally, it will know the security location, that is the services, not service side VPN, but services, services routes. Why it is knowing this firewall and other security appliance locations? Because in future, if we have some redirection rule that branch 1 should go to firewall and then it go to outside, branch 2 should go to firewall and go to outside. So if vSmart do not know the location of firewall, how you can go and write the policy? You can't write the policy, right? So that's why vSmart knowing that location of firewall, that is type 3 OMP route. Type 1 is service side VPN. Type 2 is TLOC location. Type 3 is the firewall or any other security appliance location. Okay. So far, any doubt?
Yeah, good. So,
Right. So now we know these many things. Let me go and clean the slate here. Now, why not you are showing me this in a lab? So what I'm telling here is this, that, okay, I have my, let me redraw the diagram. I have my data center. I have branch 1 and branch 2. And I have my vSmart. So suppose I have the DC. I have vSmart. I have branch 1. And I have branch 2. Question here is this, that why not whatever theory that you have shown me, why not you are showing me in the lab? Okay, no problem. We'll try to see that within the lab. So what I will do here is this, that in branch number 2, we have one router. In this router, I will go within VPN 10 and create one loopback 10. I'll put IP 10.10.10.10. /32. Okay. Now, what will happen that once I go and create this network, then what will happen? This network will get advertised where? So it will reach to vSmart, right? Suppose this router uh, system IP is 10.4.0.1. And you know the color and encapsulate. In our lab, we have MPLS and internet, biz internet. Okay. So the point here is this, that, okay, you want to reflect this route. So obviously, if in OMP, we'll go and give one command, OMP advertise connected or static, OMP advertise static, etc., etc. So that means that OMP will take this route and it will send to vSmart. So that means when vSmart will learn 10.10.10/32, it will know that it is coming via, suppose, TLOC1. Suppose this is TLOC1. You know that system IP color encapsulation, TLOC1. Since I am running the vSmart, I am running, or I am route reflector. So I will go and reflect this route here, and even I will go reflect this route here. But I am intelligent. I will reflect these routes only within VPN 10. So because this loopback belongs to VPN 10, so that means you have to go within the VPN 10, and within VPN 10 only it can see this 10 10 10 10 10 loopback. Makes sense, right? Because why it will go and advertise everything everywhere? It should be only in VPN 10. Right? You are agree with me? So can we go and perform the lab?
yeah, all good.
All right, so let's move on and we will perform the lab task related to this. OMP and TLOC, yeah, this is the lab. Okay, so let me open the device here in the SD-WAN. What I will do here, just for the sake of simplicity, I will go and create the loopback. via CLI. I'll show the CLI command as well. Via CLI, I will do. Why I will do via CLI? Because if I do it via CLI, then you will have the CLI reference as well. How we can do via CLI. You can have a look on that part. Okay. So here we are. But to do anything via CLI, you should detach the template. So I'll go here and device template, branch 2, detach the device. Okay, now I'll go here. DC branch 2. Okay, let's see. So run VPN 10. Within VPN 10, I do not have any loopback interface. I just wanted to create it. So I'll go here, VPN 10, interface loopback. Generally, you know this thing, right? You have to create this configuration via template and attach it or update it. I'm showing you from the CLI. 10.10.10.10. No shutdown and commit and quit. Now, if you go and check show run VPN 10, you can see that within VPN 10, we have one loopback address. And even if you go and check show run, show interface description, so you should see that you have your loopback 0 within VPN 10, which is up and running, right? Now, I just wanted to see that this route should reach where it should go and reach to vSmart. So can I go to vSmart and check that? So let's go to vSmart. And once we are here, we can go and check show run OMP routes or show running OMP. Not like that. Show OMP route. Show OMP routes for VPN 10. Even we can specify the subnet. Here you can see the bottom that, yeah, you have that. So let me go and specify this for VPN 10, and that subnet is 10.10.10.10. So now you will see that yes, we have this route we are receiving from this branch. Branch is 10401. And remember, this is nothing but very much your TLOC information. System IP, color and encapsulation. So you will see that. I'll show you that. So TLOC. Let's see the TLOC. So it is coming from two different TLOCs. It is coming from MPLS TLOC and it is coming from Internet TLOC. Then all the attributes, the OMP attributes that you can see here. But point here is this, that yes, it is received via TLOC. And if you go and check the summary, not detail, if you have some in tabular form, so you can see this is interesting output. Right. So from here, from vSmart and system IP, so you can see TLOC IP, color and encapsulation. So point here is that it is receiving. It got received. Now what we can do here is that now we can go to any of the other location. For example, if I go to DC1 VH1, and here if I go and check show run or show OMP routes, let's do show OMP routes for VPN 10 for 10 10 10 10. You can see, or maybe let me show you the summary first. Show run OMP or show OMP routes for VPN 10. So now you will see that it is receiving the route. From where it is receiving the route? From this vSmart IP, the 12 12 12 12 12 12 IP is vSmart IP. Then this is CIR. You can see the definitions of CIR. It's like confirmed, installed, like that. So installed, chosen, C for chosen, installed, resolved. So this is the correct route which is resolved and installed, which is coming from this particular branch, because this is the TLOC information. So other device also know the TLOC information while it is installing, because anyways it is getting from the vSmart, and vSmart will tell other device also that see, this is the IP or this is the prefix you are learning, and this is the TLOC information, you should have this. Okay.
And in this scenario, which TLOC is preferred one?
So this is equal cost multipathing, both will be preferred.
Okay.
But if we want
Okay.
to prefer one TLOC versus other, then we can associate some policy and wait with that policy, like TLOC preference or other things.
Okay.
Yeah. All right. So good job, guys. You are able to understand the OMP and TLOC. That's very much it. Now you can go and refer any of the book, or even I have shared nice documents. You can go and check that OMP and TLOC. And then like BGP, OMP also have some sort of best path selection criterias. Like it will take the valid next hop, then it will go and check the OMP preferences, then it will go and check the TLOC preferences, then it will check what is the origin, like OSPF, EIGRP, etc. Like BGP is doing, OMP is also doing, but OMP is very much simplified, because whatever things that we have in BGP, that was there in mind, and then they have developed this OMP. So OMP is very much like, easy to understand and grasp. And likewise, we have redistribution concept as well. So let's quickly talk about this redistribution concept within the OMP, and then we are very much good with this OMP topic. So suppose if I have router 1 and it has some prefix X, and then obviously here you are running some OSPF EIGRP, that will be your service side routes, and here you are running OMP. OMP is something that has big database, so many number of routes. So do you really want to advertise or redistribute everything, all the routes that you have in OMP to OSPF? By default, you can see that they are redistributing within the VPN. VPN 10 by default. We haven't done any redistribution within the VRF, right? So if you are creating some route in VPN 10 or 20, so it will go and advertise only within VPN 10 and 20. So that intelligence it already has, right? It has that intelligence already. So point here is this, that yes, if you want to advertise some routes from OMP to OSPF, so you have to go to OSPF, and then you can go and redistribute OMP. But if you have to go and send something from OSPF to OMP, then you have to go to OMP, and then you have to use the keyword advertise OSPF. While you are redistributing OMP within OSPF, you can go and use some route policy as well, just to filter the routes, because OMP table will be very big and you don't want to send all the information that you have in your OMP table to your IGP. So what I'm telling here, let me quickly show in the configuration. So if I go back here to the data center, and if you go and check the configuration for OMP, you will see that we have this redistribute connected, redistribute static, etc., etc. Now, if I go here and if I show you the VPN wide configuration, so within the VPN wide configuration, you can see that within VPN 10 itself, I am going within OMP, and then I am advertise OSPF and advertise the static. Now, here you can see the OMP thing, right? Now, if you have to redistribute, so you can see the OSPF and redistribute OMP. So those examples are there. What I mean to say here is this, that you have your internal OSPF route. If you want to send outside, what you will do, you have to go to OMP and you have to use a keyword advertise like this. Advertise OSPF. This is one-way redistribution. But if you're looking for two-way redistribution, that means if you want to send OMP within the OSPF, so your OMP routes within the OSPF database, then you have to go to OSPF and you have to redistribute OMP like this. Okay,
Yeah, okay, good.
great, good job. All right. So as per our agenda, the next topic that we have is the policy section. So let me quickly go there and see. The next topic is SD-WAN policy. And in that, we have to understand the SD-WAN policy, and then we have to understand these topics like, policies and all. With interest of, students. Thanks for joining. Today we have very important session on Cisco SD-WAN policy. This is as per this agenda, the third week. We have this topic, introduction to SD-WAN policy, and then we'll go and check hub and spoke policy. Even in the CCI type of exam also, we have such type of policy. And then we have multi-topology and route linking. So what I will do, because this is day 1 related to policy, so I will go and cover day 9, 10, and 11, only up to here. Whatever time it will take, I will go and cover up to here only. Okay. All right. So let's try to understand the policy first, the Cisco SD-WAN policy. Today we are going to learn about the policy. Now, who is the engine to drive the policy? From where you are doing that? You know that, right? VS Smart.
Smart.
So VS Smart is working as your policy engine or policy plane, you can think. In local area network, who is your policy plane? In local area network, your Cisco ICE is your policy plane. Like in SDA environment, software defined access environment, SD-LAN environment, the ICE is the policy plane. Here you have the VS Smart. Okay. So now when you go and learn about this policy, actually policy, we have two different type of policy. We have control policy, right? And control means very much routing in SD-WAN. And we have data policy. Now, data is directly connected where? To whom, which devices, like where it is connected. Obviously, the edge devices where actual data movement is happening. So this is very much connected to edge devices. Control is associated with what? vSmart, right? Now further, we have two categories: centralized, centralized, and localized. Further in data policy also, you have two categories: centralized and localized. So that means that the policy that we have, if I go and read that policy, that will be central control policy, local control policy, or centralized data policy, localized data policy. Centralized control policy, localized control policy, and centralized data policy, localized data policy, right? Any doubt so far? Any question, any doubt, anything?
No, good so far.
Great. So this control that I'm telling you, this is assume this as a routing control, actually, very much routing type of thing. Most of the time, assume this is routing. Okay. So if I have to go and take a decision related to the routing, so which policy I will go and use?
Control policy.
Right, control policy. So centralized control policy. Now there is one difference in between centralized. Centralized means what? Central location. That means vSmart. You have to go and create the policy to vSmart and then it will get pushed, right?
Mhm.
And when you push this policy, so suppose here I have vEdge devices. Now check the difference. I have vEdge devices, right? And I will go and create the policy at the rate of vSmart. And then if it is a centralized policy, how it will get pushed to vSmart, from vSmart to vEdge via OMP update. So either it's a centralized control policy or it's a centralized data policy. How it will get pushed? Via OMP update. Now what about this localized, the name localized? The name localized. This is something that you have to create some local policy and then you have to call in the template, in device template. For this, examples are QoS, some ACLs, port mirroring, etc. For this, the example is route policy, redistribution type of policy, OMP to OMP to OSPF, OSPF to vSmart, like that, right? Like the route redistribution that you are doing. So that is the example for that. Any doubt? I'm building it slowly, so you could understand this, right? Slowly, because it's a big data, and this much data is there that chances are we can get lost in the policy and all. So that's why I want to go slow. So far you are good, okay? You're able to understand the flow and all.
Yeah, so far good.
Yeah, just
Okay.
one question. So this localized policy is always called in the device template. It's the rule, right?
Yes, from the
Okay. So
device
it's
template.
never
Yeah.
okay.
And I told you earlier the flow. So, okay, anyways, whatever thing you will do from vManage, right? And from vManage, you can go and create the policy. And then it will get pushed to vSmart, right? And from vSmart, it will go and push to vEdge, right? The policy. How with OMP update? Try to understand this. And this from vManage to vSmart, what is there? I told you earlier, Netconf. So this is what? This is about the centralized policy. Centralized means either it's a centralized control policy or data policy, right? But if you go and push this directly to vEdge via, obviously the protocol is Netconf policy. So that will be your localized policy, right? Localized policy. Either it will be localized control policy or localized data policy. Oof, it's busy slide. I can understand, but this is what we have in Cisco SD-WAN, how it is in Cisco SD-WAN. Okay. So shall we proceed further?
Yes.
Yep, good.
All right. I wish I could not have this. 1 second. 1 second, let me remove this. I need one slide here. Oh, add slide below. Okay. So what we have done, let's see. Policy. Centralized policy or control policy, data policy, then centralized, localized, centralized, localized, right? Okay. Now try to understand more about this control policy and data policy. Control policy and data policy. We'll try to understand more about that. So there is one rule called CAE. CAE. Okay, I'll mute yourself. If you have anything, you can unmute and ask. So there is one rule called CAE. What does CAE rule will do? CAE, C stands for configure, A stands for apply, and E stands for execute, execution. Now, if you do CAE at the level of vSmart, that will be control policy. But if you do CA at the level of vSmart, but if the execution will happen at the level of vEdge, that will be data policy. So what does it mean? It means that the data policy that we have, it will be downloaded via the edge devices. So if you go and check show run policy from vSmart, you will see that. You will see that policy within the devices, within the edge devices, right? So first difference in between control and data policy, that the CAE will happen at the level of VS Smart. Here CA will happen at the level of VS Smart, but actual execution will happen at edge device. That's the difference between data and control policy. The difference number 2 is that this will be downloaded via the edge devices. Okay. So let me go back here and write it. At least I will go and give you three differences in between them that will help you to understand more about this context. So difference 1, 2, and 3. 1, 2, and 3. They are actually very important differences that we have in the data policy and control policy. 1, 2, and 3. First of all, CAE, configuration apply execution at the level happen with VS Smart. CA will happen at the level of VS Smart, but E will happen at the level of vEdge. Okay, then this policy will send via OMP update, but it will be there with VS Smart. This will also send via OMP update, no other option, update, but this will be downloaded, say downloaded via VS devices. The third difference is very important. This policy is unidirectional. Sorry for that. Directional. This will be bidirectional. That means that when you apply the policy, it will be in one direction. Either you will apply out or you will apply in. But when you apply this policy, it will be applicable into out, out to in. And that's why, as an architect, we want to apply more and more data policy. Because if data policy is there, then I will be free related to the direction, right? I will be free related to the direction, and I will be more than happy that, okay, this is going in right direction.
Okay, so you mean to say that this is the preferred way how to do it via data policy?
In other way, I can say that suppose to do one task, right? One task, you have both the options. Either you can do it with control policy or you can do with data policy. So do it with data policy if that option is there. If no option is there, that task you have to do via the control policy, then do it via the control policy only. That I try to tell here.
Yeah. And so if you do via data policy, then you have like less number of policies to create, like half.
Yes. Yes. Yeah. So far, so good. All right. So let's check this. So we have policy, right? What type of policy we have? We have control policy and we have data policy, right? Then this control policy and data policy, we have centralized and we have localized. We have centralized and we have localized policy, right? Now, why not let's go little bit deep into policy. So this policy, whatever type of policy is this, control policy, data policy, doesn't matter to me. Can you tell me more about this policy structure? What will be the skeleton of this policy? How this look like and all those things? So either it's a data policy or control policy, right? This policy itself having some building blocks. So policy, building blocks. How this policy looking like, right? So the first thing that you will go and define in the policy, that will be interesting traffic. Who are the parties for whom you are writing the policy? Interesting traffic or interesting or interested, whatever. Say interested parties. Who are the parties? What are the application? What are the subnet? What are the VLAN? What are the, not VLAN, but VPN? What are the application class? You know, who is interested? To whom you are writing the policy? Interested parties, right? Those interested parties we are defining in SD-WAN as a list. So in this list, you may have prefix list, VPN list, site list, app list, SLA list, blah, 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 right? So list example will be, list may be VPN list. List may be TLOC list. List may be app list, right? List may be, yeah, you're telling something?
No, it can be side list.
Site list, right? List may be any prefix.
Access list.
Prefix list. Prefix list also having two part. One prefix list is for data policy and other prefix list is for control policy. So two different type of subnets we can create in SD-WAN, for data policy, for control policy. Right. So like that we have list. Now once you have the interested parties to whom we want to write this, right? After that, what you will do? After that, either you'll go and create the control policy, routing policy, or you will go and create the data policy. Right. I'll come to this control and data policy. Then third thing, the last thing that you want to do, that you want to apply. Now, when you apply, this is 100% of time we are applying the policy with respect to site or site list all the time, right? And here your intelligence will come into the picture that if it is a control policy, you have to apply it in or out. Out means that from vSmart going towards edge devices, and direction in means that from edge devices it is going towards vSmart. So here the direction will come into the picture for control policy. You have to define the policy going egress or ingress, out, in, out. Okay, any doubt so far? Good, right? All right, so let's understand more about this. So now we have policy, and policy you have control policy, you have data policy, and here you have the centralized policy, localized policy, centralized policy, localized policy, right? Then I told you that in policy, there are three components that you have to do to make this policy successful. First is list. Second one is the policy itself. Policy itself is either control policy, data policy, right? And the third piece is apply it. Apply it, I'll write here in, out. Good. Right? So far, you're good? Any doubt? Any question, please ask.
Yeah, good so far.
Okay, so I'm going to take some 5-minute break because I got my tea. So let me pause this recording just for 5 minutes. Give me 5 minutes, I'll take tea. Meanwhile, you can also have a snacks or something. Let me pause it. So where we are now, that so the list is there. We will check list what this list will do and all. Policy that we need to understand, either it's control policy or data policy, but the structure for policy will be the Same. So how this look like? Let's focus on policy, and the structure will be very much like MAD. So we'll see that very much like route policy or any other policy that you already know within Cisco devices. So when we have the policy, I'm referring this as a MAD, match, take action, and then finally default action. So how it is that you have to go to some sequence. So policy, when you start policy, you have to go to sequence 10. Let me do one thing. Sequence number 10. If you are in sequence number 10, then match and take action. What you want to match, and then you can take action. Then you can go to sequence number 20, and then again match and take action. Likewise, you can go to sequence number n, and then you can go and match and take action. And by the end of all these policy, there is one default. By default, block everything, like in access list or Cisco access list, we have that rule. So that means that this policy structure is very much like MAD, match, take action, and finally you have to deny or block all. So this type of a structure we have, MAD type of a structure we have. Okay. So I will show you the example, don't worry, how this look like. So if I have to go and write any policy, we have, oh, Tony has dialed in. So we have examples today related to hub and spoke policy and others. We will check that. So once you have the list, hi Tony, thanks for joining. You are almost 40 minutes late. Yeah. And once you have policy, either data policy or control policy, then you will go and apply it. No problem, we'll go and apply it. Now this policy, either we are referring this as a data policy or control policy, you will come to know that this policy that we have, right? It may be app route policy, so control policy, maybe hub and spoke that we have to work on that, route leak that we have to work on that. These are the examples. Then you may have service chaining policy. You may have VPN membership policy. These are the examples. Then about data policy, the data policy may be one of the best example is app route policy. Then you have the policy related to cFloat. A data policy name itself, data policy will be working as a data policy. Control policy name as a control policy will be working as a control policy. So these are the things we have. So now let's go and take one example related to policy, how we can go and frame it and apply it. So we will understand more about it. So let's see how we can go and work on that. So suppose we are going to work on one of the control policy, and that control policy is nothing but hub and spoke policy. So we are going to work on control policy, hub and spoke, hub and spoke. So what does it mean, hub and spoke? Let's see. Let me go and draw one hub location and two branches.
So it's the same as the VPN star, right?
Yeah, right. So I have DC, and then I have branch 1, and for example, I have branch 2. Now in branch 1 in our lab, we have 2 routers. In branch 2, we have only 1. Then in DC, we have 2 routers. Okay. So we know that in SD-WAN, at the moment you will go and bring up the control plane and data plane, they will go and form the IPsec tunnel in full mesh type of thing. So I'm showing it. Obviously, you have IPsec tunnel like this also, full mesh, and with these devices also, right? So at the moment you'll go and bring that fabric up, you have this IPsec tunnel fully formed, right? But here, what we want, so here you can see that branch to branch IPsec tunnel is there. In our case, what we want, that we don't want this tunnel or We don't want this. We want that traffic should go from one location to other location via hub. Right? So how we can go and achieve this task? That's the question.
By hub and spoke policy.
Hub and spoke policy. So what this hub and spoke policy will do to achieve this behind the scene? What is the mechanism to do that?
So we will control those flows, basically.
Okay. So if somehow we can go and invalidate this tunnel, this IPsec tunnel. So if this IPsec tunnel is not there, or if this IPsec tunnel will be my backup tunnel, it's not my primary data link, then obviously the traffic will go via some other route, right? Now you want to break this tunnel down. How you can break this tunnel? So how they are forming the tunnel will come to that point. VS Smart. You are sending your IPsec key and your TLOC information to whom? VS Smart, right? Then VS Smart is working as a route reflector. So it will tell this device about the TLOC and other device IPsec key, because VS Smart is working as a key manager plus the route reflector, right? Key manager and the route reflector. It is working like that, correct? Right? So somehow if the VS Smart will go somehow and it will not send the TLOC information to other devices, so they will not go and form the IPsec tunnel. Right? What do you think about this logic? Agreed?
Yes.
Great. So that's the hub and spoke behind the scene. And not only that, because since this is SD-WAN fabric, we have control about the routes as well. You have the control about the routes, right? So not only that, but you can control the routes as well, that which particular subnet or prefix you want to send from where to where. That control is also with us in this case. So that also we will see. Okay. So let me show you this. But behind the scene, this thing will happen. I'll come back and to the drawing one more time. But first, let's go and do this. So let me open that vManage. Let's go to vManage. Because in the policy builder, I'll show the policy builder here. You have all those options that you can see in the policy builder. So here I am. And here you can go, right? In the menu. And you see the configuration and the policy section, policies. I told you earlier that we have centralized policy, localized policy, but I told you earlier that policy we have data policy, we have control policy and data policy. Both control and data policy have centralized and localized, right? Now, this diagram 1 second. First of all, I'll show you hub and spoke policy. So if you have to go and create central policy, you can see central policy. Even you have custom option as well that you can go and create the policies and all. Multiple things are there, but I just wanted to go slowly here so you will understand each and everything. So here we are. I want to create policy. So for that, what I will do, I'll come here and I'll click add policy. This page, this button. So I'll come here and I'll click add policy. Now the first page you will get, this is what? The phase one. I told you earlier, if you watch the recording, you will see, I told you earlier that interesting traffic, group of interest. This is what? List page. What type of list do you have? Application, color, community, data prefix, policies, prefixes, site, SLA, TLOC, blah, 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 blah. So many, right? Then what I want here, I told you earlier that whenever you apply policy, it is 100% of time with respect to site. And here I want to control little bit TLOC as well. I will come to all these things because we have to work on different policies. So don't worry about that. This is the list page. Then I can go next. Next page is related to control policy. This page is related to control policy. Then you will go next. If you go next, this page is related to data policy. This particular page is related to data policy. Here you can go and create the data policy. You can see app route, traffic, cFloat, etc., etc. And then finally, you have the policy builder, like you can assemble all these policy. So this page is there for your apply policy page, final page. Then you can go and apply the policy. So far, so good. Any doubt? Right? So I'll go back. So what I want here, I want to show you one hub and spoke policy. Hub and spoke policy, already Cisco is giving option for that. So if you go and click this add topology here, you will see hub and spoke. Very much same type of policy we have in the lab exam as well. So I'll go and give the name. So for example, I'll go and give the name as a hub and spoke. Any name you can give. Hub and spoke.
So this is the name of the topology.
This is the name of the
right?
control policy. Topology means control policy, right?
Yeah, but later it will be name of the policy. So this is more like name of the topology, I would say.
Okay.
Because it's quite confusing, because later we'll have to also add the name of the
that
policy.
is apply policy name.
Okay.
This is the control policy name. Okay. Description also I'll give the same. Select VPN. Suppose I want to apply this policy for VPN 10. Although I haven't created VPN 10, but assume that I have created. I'll show you that. Or maybe let me go back here. Let me go to page 1 where I want to create one VPN. I want to apply this policy to VPN 10. So here you can see new VPN list. Either I can use whatever already there, or I can go and add mine. And then site also, this policy I want to apply to all the branches. To all the branches. My branch ID is starting from 300 and 400. There's a site ID. Okay. All right, great. So now we have the interesting parties. Now I can go to the topology. And once I am here, I can add the topology. Hub and spoke. That's the name. For my VPN 10. Right. So add hub. Who is my hub? My hub is the data center, say DC1. And who is my branch? So first click there. Say choose this and then this. So then I will go and click add first. Oops, sorry for that. I'll go and click add first, and then the spokes. So my spokes, my branches, to all the branches, add it. So I have added the hub and spoke. Then below you can see some advanced option, manage custom preference and the prefix list. If you have that TLOC that you have created, you can go and use the TLOC. TLOC means the next hop, so it will go and um, prefer the data center TLOCs, right? How to create this TLOC list, I will show you that, how to do that. But if you want, you can prefer that, no problem at all. The first option you can see here, what it is telling, all hubs are equal. I can uncheck that, there is no problem on that. Now if I scroll down, okay, leave all these things default, 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 default. I can save the changes here. So this is my hub and spoke policy. I can go and save this control policy. This is what? Topology section, whatever, or VPN membership, whatever you're seeing, these are the control policies. So my control policy name is hub and spoke. Hub and spoke I created and preferring some DC TLOC as well. We can create DC TLOC list as well. I'll show you how to do that later on. Then I can go next. Now this page I will skip. Why? Because this is data policy page. And at the moment I don't have any data policy. So I will go next. Now this is the apply policy page. This is the policy that I will apply from vManage to vSmart and then from vSmart to Edge. That's the name. So the name will be apply it. I just want to apply it. Like here you can see all the options related to control policy, data policy, data policy, data policy, role and regions. All those options we have. So this is my control policy name, hub and spoke for VPN 10. I should go and give the direction as well. And okay, I'll show you the preview. Let me click preview here. See, its direction is already selected, outward direction. So here you will see the CLI equivalence of this policy. Save this policy. Even saving the policy will not have any impact until unless you will go and apply it. Now, if you want to apply this policy, careful. Your vSmart should be in vManage mode. Otherwise, this policy will not take effect. So make sure that in your configuration template part, that the vSmart that you have, it should be managed via vManage. It should be attached. The vSmart should be attached, right? So it is attached. You can see if I click here, number 2, you will see that 2 of the vSmart, they are connected. So now let me close it. Let me go back. Let's go to policies and let's activate this policy. So I can go here. If I scroll down a little bit, click these 3 dots, click activate, activate, and click activate. So before activating, I just wanted to show you the IPsec tunnels, and then I'll activate and then I will show you that. So in that way, we can verify it. So if I go to branch number 2, and if I go and check show IPsec inbound connections, see, 10.1 is data center system IP. I am at 10.4. My system IP is 10.4 and 10.3 is other branch. See, my IP is 10.4. My IP is 10.4, 10.4. 10. What is this? System IP color encapsulation. System IP color encapsulation is nothing but your TLOC information, right? So I have 10.4 has tunnel with 10.3, 10.1, right? I have all the tunnel. Once I go and apply this policy, you will not see 10.4 pairing with 10.3. Why? Because with the policy, it will be breaked. So you will see only 10-4 pairing with 10-1, 10-1, 10-1, 10-1. Only 4 tunnels you will see. At the moment you have 1, 2, 3, 4, 5, 6, 7, 8. After applying the policy, you will see less number of tunnels. Why? We will see. That also I will show you how to check that. Okay, so let's go here, go back, click activate. This policy is getting activated. Why not? Let's go and open the VS Smart. So I will go and open VS Smart and I'll show you show run policy. So this policy pushed from where? It has been pushed from the vManage to VS Smart, right? And what are the components of this? I told you 3 components. Remember 3 components we have. The component number 1, interesting traffic. So where is that interesting traffic? That is nothing but your list. So I have VPN list. I have TLOC list where I have system IP color encapsulation. I have site list. I have site list. So this is what? This is number 1 list. Then number 2 policy, control policy. Name is whatever ABC. I told you, right? Sequence and MAD thing. MAD, match, action, and finally the default action. So this is the default action. Then you can see the set of MA, match, action, match, action. Matching the site list with the VPN, take action. Match, take action, match, take action, match, take action. Right? Match, take action for VPN 10. So far, so good. Any doubt? Clean this. So you can see 1 number and then you can see 2 number. Number 3 is missing. That is apply policy. That also I will show you in a second. But let's try to understand this control policy. What exactly it is telling. Match the route for data center for VPN 10. Accept it. That's the sequence 10. Sequence 20. Match the route for all the branches for VPN 10 and send towards the TLOC. This is the policy, exact policy that we are creating. Match the TLOC of DC and set some higher preference. This is the policy, right? So once you have this policy, then the step number 3, show policy or apply policy or show run apply policy maybe. Show run apply policy. This is the 3rd number, step 3, apply it. So to all the branches to the outward direction. Now, once you apply this policy, what will happen? Number of tunnels will decrease, right? So if you go here and check, see now I have tunnel only with data center. Now there is no spoke to a spoke tunnel because we have break down that spoke to a spoke tunnel. We broke down that. We don't have that now. It's gone.
So this apply step is in the languages of GUI is that activate, right? It was
Come
the
again, activate.
action. This is the apply step.
Apply, activate. Yeah. So if you go to policies, now you can see this is true. Activated.
So it means applied. Okay.
Applied, yes. Right. So this is your very interesting policy. You try to understand that policy. Now, so we completed this. We have checked this. We are doing this already. Now, there is these policies, multi-topology, right? And route. I'll come to route leak. At least let me try to explain you about multi-topology, right? Because this is associated with hub and spoke policy, this multi-topology. Okay. So multi-topology means what? Just now we discussed about hub and spoke policy. What we have discussed in hub and spoke policy? Now try to understand this thing. Hub and spoke policy that we discussed just now, that I have routers in branch. Assume this is branch and data center, and these are the routers. But point here is this. Let me write. So later on, say this is branch 1, this is branch 2, this is DC1, for example. This is having site ID. This is having site ID 300. This having site ID 400. So point that I'm making here is this, that hub and spoke policy, right? The hub and spoke policy traffic will go in this direction. Hub and spoke. But one thing you have seen there, that this policy, the hub and spoke that I use actually, that is what for VPN 10, not for VPN 20. So what I'm telling here is this: if I go and check IPsec tunnel for VPN 20, VPN 20 traffic is still can go in this direction, because I haven't applied that for VPN 20. So that's the point here. That's the multi-topology option. So now what I want that for few VPN, the traffic should go via hub and spoke. So for example, for VPN 10, it can go via hub and spoke. Just an example. And but for VPN 20, I have one firewall here, and I want to send the traffic via firewall. And then I have one VPN 40, even it will never form the IPsec tunnel. This VPN 40 I have for internet, or this is for guest traffic, for example, guest traffic. And what I want this event do not try to form IPsec tunnel. Do not form IPsec tunnel. You're not allowed. You are there for DIA. So any traffic related to VPN 40 is for local breakout. Use internet. Even you will never try any IPsec tunnel. This thing can be happen with help of the concept of called multi-topology in SD-WAN. SD-WAN is providing you this option of segmentation, or you can say in other words, this is very much segment routing, right? This concept is not new. Segment routing using this thing. Segmentation or VRF. VPN is nothing but VRF. VRF routing or VRF internet route leaking, etc. You can give any name. So this can be achieved within SD-WAN within 10 minutes. You can go and apply this type of policy within 10 minutes. What you can do for few of the items. So for example, for VPN 10, I will go and create policy that will go and use the hub and spoke. For VPN 20, I will go and use some service redirection, and done. Okay, so let me show you how to do that. Some examples are already there in this lab as well. You need to parse that. So for example, this one, multi-topology plus firewall insertion. So let me copy this policy. Let me show you in the preview. I will create it. Don't worry. I'll create it. I just copy this policy in CLI and I'll show you. We'll create it from scratch, but I will take a reference. You can also take a reference like this that I'm using. You can also use, because it's very hard to memorize all the policies and all, right? So VPN membership policy is something that is very easy. Let's try to understand that VPN 10 Corp VPN accept, VPN 20 Corp. So what it is telling, this is a small 4-line is telling that only VPN 10 and VPN 20, they will form IPsec tunnel or try to form IPsec tunnel because they are part of VPN membership policy. Any doubt, please feel free to ask about VPN membership policy. Any doubt, please ask.
Just one thing you didn't show that you said before the creating that policy before, in the last step there was like direction of the policy.
I
I
will show
didn't
now.
quite get where we
It
can
was
make
by
it.
default there in that builder, policy builder. So now I
And
will
if we
show you the
want to
direction
change,
first.
okay.
Yes, so you can create custom policy. Now we are going to create custom policy. You will see that.
Okay.
Yep. Any doubt, please feel free to ask. I'll give you 1 minute time for that. If you want, if you're thinking something, you can think and ask.
So by default, it's out, right? The direction.
Control policy for hub and spoke, yes.
Okay.
Ten, 20 more seconds. No questions, then I'll start. Okay, seems no questions, then let's just start. So I'll create that VPN also, but we are going to focus on this control policy. What this control policy is saying, let's check. So match the route for all the branches for VPN 20 and send towards the data center. So our logic is this, that VPN 20 will be hub and spoke and VPN 10 will work as a service redirection, means the traffic should go towards the firewall and then it will redirect it. Okay. So let's do that. Let's go here. And this time I'll go and create all the objects and everything. So let me go and start with the policy. You can see you are here in the centralized policy, add policy. Okay, and I want to add. So actually we have all the sites already there. I have all the VPN. I'll go and create one more VPN, that is VPN 20. Okay. Then where I want to apply this policy, I want to apply this policy to all the branches. So that site is already there, all the branches. I don't have the TLOC list, so let me go and create the TLOC list. This is there, I can use it, but let me show you how you can go and create the TLOC list towards the DC. Okay, so my data center 10.1.0.1 color is this internet and encapsulation is IPsec. Even if you want, we can give the preferences. 10.1.0.1, this time color is MPLS, encapsulation IPsec. Then I have other edge device 10.101 and 10.102. So 10.1.0.2 and oops, biz internet and IPsec. And then finally 10.102 MPLS, and it should be MPLS. So let's go to drop down. This is my TLOC list. 10.101 Internet MPLS, 10.102 Internet MPLS, right? Click save. I have all the interesting traffic. Now we can go next. Now, this time we don't want to create the inbuilt policy. We want to create custom policy. So I'll go and click custom policy. And this is my actually hub and spoke and plus a redirection towards firewall, firewall redirect. Click this. What you want to match in custom policy? I want to match the route. Okay. Okay, great. So I want to match in the match statement. I want to match the route and the VPN. So I want to match the VPN, say VPN 20, VPN 20 for the site, all branches, right? Now, once I will match this, then what action I want to take? So you can see MAD, MA. So go to action tab. Now I want to accept and I want to set it towards the TLOC. So towards the TLOC. And just now we created towards the DC. So match the, you can see, match the VPN, match the site and sending towards the DC TLOC. I can save this, right? Let's see. So match the route, oops, from here. Match the route to all the branches for VPN 20 and send towards the DCT log. Then other sequence. Match the route for VPN 10 to all the branches and then this time send towards the firewall. Same type of policy, just the things are different. So what you can do even, you can copy here this item and then edit here. So this time I want to match the VPN, that is VPN 10 for all the branches. And this time you want to take the action that you don't want to send towards the TLOC, but you want to send towards the firewall. We have actually firewall in VPN 10. So I can go and give the number, say 10, service VPN 10, save and match action. So now we have to, right? Let's go here. Default action will be there. Oh, done. So this policy is done, right? Then guest, leave this guest at the moment and leave these things, but we have the list. Simply we have to go and apply it. But before applying, I just wanted to show you this VPN membership policy as well. So I just wanted to save this policy, save this control policy. Now here you will see, oops, someone is joining the room. Who is this? Oh, Tony. So now you will see here that you have this VPN as well in the same page. This is control policy page, right? Now add the VPN membership policy. I want to create new. What does it mean? Only VPN 10 and 20 will try to form IPsec. That's the meaning. So whatever number you will put here, say for DC and branches, I will not select the DC and branches. I want to do for all. This is required actually. Oh my God. Okay. Save it. So now we have the VPN membership policy as well. Next. This is data policy page, so you can leave this. Next. This where you have to apply the policy. So this page is nothing but say my multi topology apply page. Now here you have to go and add the direction and all those things. So let's see one by one. First of all, hub and spoke firewall redirect. Where you want to apply? I want to apply this to the egress direction of all the branches, right? Outbound direction of all the branches. Yes. Then what about the VPN membership? There is no direction because it is in, out, out, in. You know that. Then I don't have data policy. I don't have traffic. I don't have any of them. I want to preview it. Click preview. Now you will see sequence number 1. match the route for VPN 20 for all the branches, for all the prefixes. By default, it has generated the 000 prefixes and apply towards the data center. Then match the route for VPN 10, apply towards the firewall, VPN membership, then this, and then the list that we have created, save it. No problem. It will not do anything until unless we'll go and apply it, right? So before even doing this, let me go and remove one of the policy from this list. Make this behavior as a default behavior. So let me go and deactivate the previous policy. I'm deactivating it. Let's go back to the page here. So once you deactivate, you will see all the IPsec tunnels. Now you can see all the tunnels. So that means that before applying the policy, now we have to check for VPN 10 and VPN 20. Now both the traffic pattern will be different, right? So let me open one of the data center. And if the policy is there or not there, let's try to reach out the firewall here. So I should do the trace route within VPN 10 from one branch to other branch. That is the goal with me. From one branch to other branch, I want to trace route. So other branch 10.3.0.1 is the system IP. And also, not like this. Let me take the exact IP, right? So let me open the branch 1. Let's see the exact IP within the VPN. So show IP interface brief. Exact IP. This is the exact IP within VPN 10. 10.3, 10.2. So I just wanted to trace route for VPN 10, 10.3, 10.2. Without applying the policy, it should go direct because we have direct to direct connectivity. So it should be one hop away. Likewise, do the trace route for VPN 20 for 10.3, 20.2. Let me see. What's the IP here for VPN 10.3, 20.2? So this should also go direct. You see, this is also going direct. So what we have done in our policy that for VPN 20, so for VPN 20, how it is going? For VPN 20, this is 20, hub and spoke. VPN 10 firewall. So now if I go here and apply the policy, okay, where is my policy? Activate. Activate. It's taking time to get activated. Let's go to vSmart and verify that it got activated. Yes. Now, if you go and see the traffic pattern for VPN 20, it should be hub and spoke. It should go to the hub first and then a spoke. Now it is unreachable. This is unreachable now. I'll show you why it is unreachable. And this is good point that we can go and do the troubleshooting as well. So now I can see because of this statement. So if you create such type of policy, make sure that the default action is accept. What we have done, we haven't changed it. So by default action is reject. So it is rejecting everything. So now what I have to do here, that I can go and edit that particular policy only. Now, if you just wanted to edit that policy, you can't edit from here. You have to go here to custom options on top, check the centralized policy, and this you have to go and check this topology. Topology is nothing but your control policy. So once you check the topology, where is my policy that I created? This is the policy I created. Now you can go and click edit, select and click edit. Once you are here, then you have to go to check the default action, edit, accept. So now if you save it, it will apply to the main policy, because see, this is already active policy. So now it is updating the vSmart. Hey, vSmart, you have to go and update the default action as accept, because it is already policy in use. So now they will go there and do that work. Now if you come here, default action was reject. Now if you go and check, you can see the default action will be accept. But what is this? Is VPN members, this one, this. Earlier it was reject. So earlier it was reject. Now you can see this is accept. Wow, great. Now let's go back here and now see the traffic pattern. So for VPN 20, it should go to data center. This is the data center IP. If I log into data center device, you will see this IP 1020. I'll show this. So let me go to DC1 VS2, and if I do show interface description, you will see 10.120.250. So this VRF is what? This is following hub and spoke, right? Now, if you go and check the 10, it should go via firewall. So now you will see here that it is going towards the firewall, and in data center, we have actually the firewall installed. ASA firewall is there in this lab. So ASA firewall is there with this IP 10.1.10.200. 10.1.10.200. This is what making this very effective. This is the multi-topology lab. So what we have done last time, we were discussing about control policy. And today also we will go and learn about one more control policy, that is the route leak policy. And let me quickly add here. So we are within the day number 11. So what I will do, I will cover 11, 12, 13. And if time permits, then we will see 14 and 15. But I will go and cover up to day number 13. So these topics I'm going to cover today. Now, when we are talking about policy, so we know that, okay, we have policy, and within that policy, we have control policy and data policy, right? Now, this control policy, this data policy that we have, so we have control policy, we have data policy. Now, the problem with SD-WAN is this, that suppose if you go and create two control policies, suppose 2 into control policy and 1 into data policy, you need to go and club these policy, because at a time only one policy as a whole will be activated. So suppose I have 4 or 5 different policies, that doesn't mean anything, right? That doesn't mean anything. That means that at a time only one policy will be activated. So that means that you have to club those policies together, either n number of data policy, n number of control policy, but you need to go and club them together, then only they will make sense. So that's the key idea here about this policy. So what we will do here, that we will go and continue our building policy, that we'll go and build the route leak policy. I will give you the context about route leak policy, what it will be. And then we will go and create one data policy. And then what I will show you that I will go and add these policies. That is the day number 13, that how we can go and add the policies together. So route leak policy is different contour policy, and C float policy is different C flow policy or net flow type of policy. But how we can go and assemble them within one policy, that's the day number 13. So I'm going to cover these items today. All right. So let's see. Let me go and go to a screen where I have, yeah, here you can see I have, yeah. So first of all, what we will do, we'll go and start with route leak policy. Route leak means what? Different VRF can talk to each other. So in our design, we have two different type of VRF. We have VRF or VPN, VPN 10, and we have VPN 20. Now, suppose data center, suppose the DC. Now within the DC also, you have VPN 10 and you have VPN 20. And since they are part of different VPN, they will not communicate to each other. Likewise, suppose I have one branch, the branch 1. There also I have VPN 10 and I have VPN 20. So even in the same branch also they will not communicate, but this VPN will go and communicate with this VPN, right? Across the branches, and this 20 will go and communicate with 20. Correct? But if you go and enable route leak policy, then 10 and 20 routes can exchange. 10 and 20 routes can exchange. 10 and 20 routes can exchange. That's the whole idea about the route leak policy. How we can do it? Say the configuration is very easy and straightforward. Let me show you the configuration. I have attached here in this document the route leak policy configuration. It's very easy. Take a VPN. So suppose I have VPN 10 and 20. What I will do, I will go and take the, say, VPN. In my case, suppose I have VPN 10. So VPN 10, this is not the policy, this is the list. Let me show the policy. So how we can, oops, okay, here it is. So how we can do this? Easy and straightforward. Take the VPN 10. So suppose this VPN 10 and export to VPN 20. Then take VPN 20 and export to VPN 10. Easy and straightforward. So from here you can see match the route for VPN 10. Suppose this is VPN 10. Matching the route for VPN 10, and then we are exporting to, suppose this is VPN 20. Likewise, match the route of VPN 20 and export to VPN 10. And then go and apply this policy. Remember, this is the only policy that we are applying inward, or like, 95% of policies we are applying egress outward direction, but extranet policy we are applying to ingress. That's one difference we have, because we want to do the route leaking. Our policy flow is towards the VS Mart. So why not do this thing? Let me quickly go and connect with the lab, and let me show you the policy building. The policy building will be easy and straightforward. So let me quickly connect with the lab, and then let me do the RDP.
So basically, this is the same concept as route card
BGP import
importing.
export, yes.
Yeah. Okay.
When we are importing exporting within the VRF, it's the same thing.
Yeah.
Okay. Let me go and log into vManage. Session expired, so I need to refresh the session. Let me refresh this. Username and password. A bit slow. Okay, so how we can do this? We can go to configuration and policies. Okay, so let's create centralized policy, add policy. I need VPN 10 and 20 that already we have created last class, that VPN 10 and VPN 20. Then this time we want the custom policy, route leak policy. So what we want? We want to match the route. So we can go and take the route option, create sequence, match the route. We are already in the match the route. Match the route for VPN. So let's select the VPN here, VPN 10. And then take action, accept. This we want to export to 20. So 10 to 20, save this. Now I'll create a copy and then I will edit this. Now 20 to 10. So this I will make, instead of 10, I will make 20. And in the action, instead of 20, make this 10. Save. Right. So I can go and save this condition. Let me quickly verify here. See, default action is accept, otherwise everything will be blocked apart from that. So we'll go to default action and accept, save this policy. So we have created one control policy, right? And here later I have to go and club the policy. So I will make this all in one policy. The name is all in one policy. Later on, I will show you that how you can go and add policy in this. At the moment, we have only one control policy here. So I will go and add the reason where I want to apply this route leak. Suppose I want to apply this to obviously the inbound direction to all the branches. I will not apply to the data center. Let me apply to the all branches, inbound direction, all branches, add. Yeah, and preview. So you will see here that VPN 10, all prefixes going to 20, 20, all prefixes going to 10, default action accept, and then it's applied. I can save this policy, but this policy uh, will not take action because you need to activate it. So before doing anything, let's go here and see, first of all, the routes. So if I go and check show IP or show OMP, even IP will also, okay. Show IP route for VPN 10. In VPN 10 route, you will not see anything coming from 20. So although you are receiving, see the TLOC, you are receiving routes from data center, you are receiving routes from data center. The next stop is DC. These are the DC routes. We are some default and other. Some default and other. So, okay, how we can go and check this? So 10, I am getting 10 route. And if I go to 20, 20 routes are something like, it will be like 10, 120, 10, 120, right? So 10, 120, 10, 120, even I can see here 10, 320, 10, 320. This is from branch, right? So let's see, say branch route, any of the branch routes. See, I'll do this thing for you. So if I want to see show IP route for VPN 10, for for this subnet. This subnet is from where? This subnet is from VPN 20. And you want to see this where? In VPN 10. It will not show you, right? Because 10 and 20, the VRF, the tables are different. So 20 you can't see in 10, 10 you can't see in 20, right? Okay. Now, if we go and activate the policy, so we have all in one policy here. Okay, let me go and click activate. Already one policy is activated, so I need to deactivate or activate. So let me go and activate this policy. We are trying to activate this. Since it got activated, so let's go here to vSmart. Where is the vSmart? Sure, and policy. See that route leak policy is there. So route leak is there. Okay. Now, if we go here to branch 2, and if you see the subnet, now you can see it is learning. Now 10 is learning 20 because we have done the route leak. Okay. You're able to understand this concept?
Yes.
Easy, straightforward, right? Take 10, send to 20, 20, send to 10, very much in BGP as well. All right, so let's move to next topic. Next topic, first time we are going to learn about the data policy. So far, we have discussed about all control policy. Now, this is something that we are going to learn about data policy, the C float. C float is very much like net flow. In SD-WAN, we have to create C float template. Now for this, you have to go and create different type of things. Different type of things means that you have to create, first of all, the data policy. You will go and create the data policy, no problem on that. Like you are creating the control policy, you will go use some sequence number and use the MAD and you'll create the data policy. But since this is net flow type of policy, so you have to define that where is your collection server, like where is your external server, where you want to send the flows, what is the activity time or inactivity time sending these flows, right? So we have to go and create some sort of C float template where we will define that what is the external IP for the storage, what is the protocol used, like TCP flow you want, UDP flow you want, and what are the timers. So that means here you have to go and create this template and all together you have to apply within the policy. Okay, so let me show you. When I show you, then you will find that it is actually easy. It is not that difficult. Once you see it, you will find that this is not that difficult. Where is my lab? Okay. So I told you earlier that when you are creating the policy, now here's the problem. What's the problem? That since I told you earlier that I want to create policy, right? And that policy should be one policy. That should not be new policy that I want to create now. Should be one policy, right? That I told you earlier. So if we have one policy, then how we can go and create the data policy and connect with them. So let me show you this. What you can do now. Go here, go to policies. And on top, you can see custom policy option is there. Now from there, you can go and select one policy called traffic policy. See, traffic policy. Click there. Now this traffic policy, this is the traffic data. This is for data policy. This is for app route policy. This is for data policy. This is for cFloat. So let me create a cFloat template first. Say my cFloat template. Now here you can see I can go and define the activity, inactivity timers, etc. I'll give any random number here, the sampling intervals, etc. Then the collector information, where you want to collect these flows. So I want to collect these flows over VPN 10. And the IP, I'll give any pseudo random IP which is not exist in my network, anything. Port number, by default it will take, or I need to give. So they are using cFloat, they are using some port number 4738 or something. Let me quickly check that. What port number they are using? They are using some specific port number, although I can go and give any port number, but that port number should be allowed if in between the cFloat template and the SD-WAN device, I have some sort of uh, firewall. So whatever port numbers I'll give here, I should go and allow that port number, right? So let me quickly check the cFloat port number. I'm checking it in other screen. Some starting with 473 something is port number. That is defined. Even if you do little bit Google search, you will get that cFloat port number. I'm checking where is the port number. Port number is port number is 4739. 4739. Okay, great. Protocol, I will go and use UDP. So source interface, I'll go and give gigabit Ethernet, maybe 0/1. Okay, so I have this information. I can save this cFloat. No problem. Good. Now we will go and create the data policy. So now I will go and click here to create the data policy. Add the policy, create new policy. My cFloat data policy. Okay. So here you can see so many options are there, QoS, firewall and all. We'll go to custom. Custom means you will get all these options. So what we want now with this cFloat template, with this policy, I want to match the VPNs, for example, VPN 10, right? And for that particular VPN, I want to match the protocol UDP, right? And take action as a cFloat. So in data policy, when you apply the data policy, you will get the option related to VPN. Here on top, you are not seeing any VPN option. But when you apply the policy, you will see the VPN option. So VPN will add later when we apply the policy. What I need to do here, I want to go and match the protocol. So what is the protocol? Protocol that we are matching is UDP. UDP protocol number is 17. TCP protocol protocol number is 6. UDP is 17. So now we have matched this. Now we can go and take action. What action you want to take here? We want to take action as a cFloat, right? Save this policy. So now we have the data policy called cFloat. we have the template called mycflow template, right? Now we can go next. Yeah, I think we have created this. So now we have this, right? So we created the template, we have created the data policy. What will be the next thing that we should do here? So remember earlier we created one policy, was the policy name all-in-one. So all-in-one policy I created. That is the policy that I have activated, right? Now in that policy, I have one control policy. What's the name of control policy? Route leak, right? Now this policy is already activated. Now in this activated policy, I want to go and add. What I want to go and add? I want to go and add one more policy. This time the data policy, right? And this data policy will be cfloat that we need to add. Since this is active policy, whatever addition you will do, it will push, it will go and push that. So which places we can go and add and manipulate and all those things. You know, these things are not properly documented anywhere in this books and all. You have to go and check these type of tutorials videos where you can go and see this in action. So let's see where we can go and do that edit. So now I will go back to centralized policy. In centralized policy, we have all-in-one policy. You can go there and click edit. Now, once you go and click edit, again, I told you these things are not properly documented. So now you can see here that here on top, you have policy, apply policy. You have control policy. Topology is what? This is control policy. Then you can see traffic rules. This is what? Data policy. So if I go to topology, you can see route leak there. But now we have to go to traffic rules and we have to go and add the cfloat, right? So I can go and click here topology just to show you that see route leak is there. Now I'll see this click to traffic rules. Now if I go and click to traffic rules, again you will see all three options that we have that we can go and add application route policy, traffic data, and cfloat. So I have to go and add this also and this also. Both I need to go and add this and this. So what we can do, we can click this. And here you can see data, click add policy. And now you can see create new import. Remember we have created. So I can import. Once you click import, what's the policy name? My cfloat data import. So now you can see here, right? But we need cfloat as well. So this also we will go and click import. My cfloat template. Right. So now you have this policy, but again, see, these things are again not documented properly. Even if you import, it will not work. If I click save policy, it will throw error. Why? Because again, you have to go back to policy and you have to apply this. See, so I'm coming here. Now in data policy, you can see the difference I told you earlier. You not only have to add the site, you have to add the VPN as well. And here you are not seeing any direction because in, out, in is there by default. So now we are here and we can go here and click the site. So I want to apply this to all the branches. And then the VPN is VPN 10. So I want to apply this to VPN 10 and then I will save it. But still this is not completed. Why? Because you have to go and add cfloat as well. So cfloat is related to branch, all branches. Add. Now our policy builder is completed. Now if you click preview, you can see both the policies. You can see cfloat policy, see cfloat policy, match the VPN 10. protocol 17, all the IPs, action cfloat. Then the cfloat template, then you can see the control policy as well, route leak policy and all those information. I can click save this policy. Now, once you save this, obviously it will get activated because this is active policy. This is already applied. So if you do any modification, it will go and so vManage will go and modify the vSmart via Netconf, and then vSmart will go and update to the devices via the OMP. So that thing is happening behind the scene. Once it is done, we can go back to the vSmart and we can go and check that policy. Now you can see that we have the cfloat policy and this policy. Now again, remember one thing I told you earlier. What was that information? Earlier, I told you that, hey, if it is a data policy, it will be downloaded by the device. So since the cfloat policy is what? The data policy. So now if I go to branch 2 and if I run command show policy from vSmart, you will see that this cfloat template has been downloaded, right? Earlier, I shown you that chart about CAE, configure, apply, execute. So if it is a data policy, it will be executed at the level of edge devices, CAE. So if E will happen at the rate of edge devices, that will be data policy. And C and A will happen at the rate of vSmart. If CAE will happen with respect to the vSmart, that will be control policy. Okay. Any doubt in this? I think it's clear, right? Clear, right? Any doubt, anyone? Please feel free to ask. Yep. Okay. No one is telling anything. You guys are still there?
Yeah, okay. Well,
All right, great.
no, just digesting the
Yeah,
config.
means you can watch this video
Yeah,
2-3
in
times, so
GUI
you'll understand.
it's quite complicated actually.
These things are not documented anywhere. You can
Yeah.
watch my video and you will understand. So we have completed this route leak, cfloat, all-in-one and session on policy. Why not? Let's go and check this app route policy as well. App route policy is also easy and straightforward if you follow the process, right? So application route policy, I will explain you first. Actually, it has some terminologies. App route policy is a kind of interesting policy where in the list, you have to go and define the application. So obviously you're defining the list for any policy. Define the application. Say in my case, I will go and use two applications. A web application, web apps. In my lab, for example, I'll go and use HTTP S related application. And then to show you that how the circuits are changing, I will go and use some voice or video related app. Voice video app. Such as SIP protocol, or RTP, real-time protocol, etc. So these are the applications I will use. Now, what is happening in app route policy, that you have certain SLA criteria. SLA. You will go and define loss, latency, and jitter. If loss is, for example, 2%, latency is maybe 100 milliseconds, jitter is maybe 200 milliseconds, etc. If it will go, so if application will go and meet this criteria, means if SLA will get breached, then I have option. I can use biz internet or MPLS. So suppose my primary path is MPLS, then if SLA will get breached, then switch the circuit, go to the backup path, that is internet. Right? Any comment, anything on this?
So we can use it kind of like failover, basically.
Yeah. Failover mechanism, yes.
Or auto failover, to be more precise.
Yeah. But idea you understood, that the idea?
Yeah, the idea is good. Yeah.
Okay, so let's see. So let's go here to the policy builder, policies. We are in centralized policy, add policy. I want to create application class. I want to create web application class and application. And let me search the web application if I have. HTTP. Oh, this in the family, application family. Go to application family and search web. So web and webmail, that is my HTTP class type of application. I'll add it. Then I'll go and add one more. That is for voice and video. So voice and video class. So for voice and video class, I can go and check the family. So audio video family will be there. So this way I can go and create the classes, the application. So I have voice and video class and I have the web class. Two classes I created. So I have this and this, right? Now this I want to apply to which VPN, which site, all those things are already I have, right? So now I can go to next. This page is for control policy. Let's go to next where we have the app route policy. App route policy, create policy. Okay. My app route policy. All right. So once we are here, let's create this app route policy. Simply match the application and then the SLA. If SLA will not match, take action. That's it. So, oops. By mistake, I created twice. Click twice. Let me delete. Let me delete. Okay. So I am here. Let's click the sequence rule. Here, what I can do from here also you can edit, no problem. So sequence type, sequence rule. Once you click sequence rule, match what you want, application family. My application family I want to match. Just now I created, say, voice and video class. Then what action I want to take, even I can define the VPN as well, which VPN this is residing. So for example, this is in VPN 10. So I can go and define, since this is a data policy, so while you apply the policy, it will give you option related to VPN. So that's fine. This what you want. I want to apply the SLA for this. So my SLA, what is preferred? See, I haven't created the SLA, right? Even I can create in the list, or from here also you can create. So create new SLA class. Let's see. My voice underscore video SLA, that's the name. Loss maybe 5%, latency maybe 200, jitter maybe 200. Now they have added this app probe class, which is there in the exam. You can have a look on that. For that, you have to go to some other place, create some other things, and call here. So click save. This is one of the SLA that I want to use for video and voice. I'll use it. Now see here the preferred color. My preferred color will be MPLS. So I can go and search MPLS as my preferred color, but I want backup as well. So here on top, you can see backup SLA color. So backup SLA color, I will go and use internet for this. And then you can see that if SLA will not match what you want to load balance, you want to drop. So multiple options are there, right? That means that suppose you have your application, and if SLA will not match, so you have option, simply drop the traffic. This is called strict matching. If it is not matching, drop it. Or you can take the alternate path. This is the load balance. This is the strict drop. If it will not match, drop it, because I'm running my application over MPLS, and I know if I load balance or if I go to other circuit, that application will not run over internet. So unnecessary sending the application over internet is wastage of my time. So if it will not match the MPLS, then drop it. If it will not match the internet, drop it. Like that you can create the condition, right? So very easy, straightforward, like the conditions, very logical. So now I have this and the preferred and the backup color. I can click save this. So let me save this rule. Then I can create one copy and edit, because this time I want to match one other policy, that is a web class. So let me go and search where I have my web app class. Now for this web app class, the SLA, I want to create new SLA. My web class, oops, SLA, and loss is maybe here I have more tolerance, maybe 15%. Latency maybe 500 is okay to me. Jitter maybe is too much. 300 is okay to me, like that. Save it. My web class. So here I can go select my web class SLA color. So here I want to prefer internet. And if it is not match the internet, then drop it. So I need to remove this. Save. Now there is one beauty about this app route policy, that app route policy is the only policy where default action is allowed. Rest all the policies, default action is blocked. So you don't have to do anything here. Default action is allow only. If nothing will match, then it will go by the default tunnel or default circuit, whatever circuit is available. Click save this policy. Now our app route policy is done. Now either I can go and add this in all in one policy. I can do that, no problem. Or let me go and create some new also, like my app route policy. App route. So now you have to go and apply this policy with respect to VPN and site. So I will go and apply this to VPN So all the branches and VPN 10, right? And click add. Now we can go and click the preview, the CLI equivalence of this policy. So here you can see that we are creating the SLA for video, for web traffic. And then in the policy, what we are doing, VPN 10, video and voice traffic for all the source IP. The preferred action for video and voice is MPLS. Backup is internet. If anything will happen with MPLS, go via internet. Likewise, the web application preferred is internet. If it will not match the internet, drop the traffic. That's it. Then you can see that list of the families that we are adding here. We have added the family, and in that family you have these many things like database, peer-to-peer, web, audio, webmail, blah, blah, blah. So many, right? And then we have applied this policy to the VPN to all the branches. So now we have this my app route policy. Why not? Let's go and activate this policy. So I will go here, click activate. It's activating. Progress. Now, if you come here to the VS Smart, and if you go and check, it should be here, the app route policy. And since this is data policy, it should be downloaded by the devices. So here you can see it is downloaded. Now, how to check this? So let me show you that how you can go and verify this. So first of all, let's verify this policy. Show app route stats. You can see the stats here. So different tunnels are there from where it is going, the traffic is going. And the app route stats, you can see in the tabular form. So traffic is going here from different tunnel. Now what we can do here, that let's see one of the traffic, which circuit it is going. For example, voice and video traffic, how it is flowing. Let's try to understand that part, voice and video traffic. So if I go and check, so policy, tunnel path for VPN 10, interface is this source IP. I know this branch having source IP 0.1 and destination IP. This IP is communicating from branch to data center. Assuming in data center, I have the applications servers hosted. Protocol is, say, I'm going to check the voice video protocol. That protocol is UDP, that is number 17. And then the application, suppose I want to check the SIP protocol or RTP. So let me try a small SIP. See, and then I want to check the RTP, real-time protocol. See how you can check this. Show app. Let me show you this DPI. Just wanted to show you that how many applications are there within VPN 10. So for that, you can go and check show app deep packet inspection application 10. So here you can see clearly that within my VPN 10, I have RTP protocol running and I have some Skype running. In this lab, we have behind the scene some simulation is there. So these protocols are running behind the scene. You can see the web is also there, web is there. But we are focusing on audio video, family audio video. So yes, it is there. And this application is using what tunnel, it is using MPLS circuit. From here to here, MPLS. Now, if somehow I can go and generate the loss and latency within the circuit, then from MPLS, where it will go? Via internet. So in this lab that you have, there is simulator. So branch number 2 for MPLS, I want to add latency. So if you go and add the latency there, and now if you go and check show app route stats, you will see slowly the latency will picking up. Slowly you can see the latency will picking up, and once all these buffers will get picked, like filled up, all these multipliers get filled up, that means the latency will go and bridge. So what is the SLA? Let's see. Show app route SLA class. So permissible SLA is 200. If it will go and go more than 200, so it will go and change the circuit. So now you can see it is going via internet. Earlier how it was? It was going via the MPLS, but I have generated the latency, and as per app route policy, because we have the backup path, now it is going via the internet. Now if I go and remove the latency, and once again the counters will start clearing for that latency. Oops, the stats. So if you go and see, so now everything will become 0, 0, 0. So after some point of time, after a few seconds, you will see that it will fall back. It will fall back to MPLS. Okay, guys, any question, any doubt?